Okay, it's supposed we are supposed to be live now. And Matt, how are you doing?
Good morning, Brian. I'm doing very well, thank you. Super looking forward to today's DevSecCon24. How about you?
Absolutely. We are about to start off the EMEA part of DevSecCon24, and I'm glad that you are with us or still with us, and I hope you enjoyed the American part and the APJ part. All that is already passed. Like for us, yesterday. Well, because for us it's morning now, right? So let's get right to it. I will share my screen for a second, and I will get you through the whole system how this all works. So as you can see, this is normally where you end up, or well, basically you will start with the DevSecCon page like you see over here, and you can go to agenda to see what is going on and what we can do. As you can see, the two streams are already up: the pre-event kickoff and the welcome, the EMEA stream and the DevSecCons for Kids stream. And that's one that is very nice. That is especially if you're here and you have kids around and you try to work from home and you need them to be entertained. Go to that stream and basically you can put your kid in front of it, or me. I like it as well. So that
I don't think we're allowed. I wanted to be on the DevSecCon for Kids stream, but apparently there's no grown-ups allowed.
Oh man, I will just do like this. Maybe they believe me now. Let's try it out. I will try it out later. But anyway, you can go in the streams. I will not go into there because you probably are there as well, and we don't want any echo. But you see it over here. There is a chat window in there, but most of the chatting and Q&A happens in our Slack. So I would urge you, I won't beg you, but I want to ask you to go to our Slack community, and you can see a couple of channels dedicated to DevSecCon24, and there is also a live channel. In that live channel, all speakers will do their Q&A. So I think it's best over there. You can look it up afterwards. You can connect with that speaker afterwards. So that will be a good thing. As I scroll through this window, you see that there's already a large part done because that was the APJ and American part. But when we come to the sessions, APJ closing, when we come to the EMEA part, you see that we are starting with Guy Pajorni's session on cloud native application security, embracing the developer first security for the cloud era. You can click on that and you can go in. It will be live like 2 minutes before the session time started. And you can go on and on like this. It's pretty straightforward, so I don't think you will have any issues with that. So, how about you? Did you look at part of the APJ and American part, Matt?
Yeah, so I did a panel for the Americas one and did the live chat for that. So that was cool. I really enjoyed recording that panel. I think there's some great content coming up today. I'm really looking forward to today's panel, which is the one about measuring DevSecOps maturity. And I know we've done folks that we know well, Alyssa and Patrick, did a lot of work around that in the last few months. And I'm also super looking forward to the eBPF session later on, which is eBPF, a super interesting technology in the Linux kernel that gives you lots of insights into what's going on in systems at runtime. So yeah, that'll be great. I think we should also show folks the sponsors page, right, Brian?
That is an absolutely good thing. So let me add my screen again. And of course, on the top, you see the sponsors. And if we go to the sponsors, you will see all the different booths we have, virtual booths we have, like, well, this company is quite unknown to me, Sneak. I have no clue what they do. But we've got Bridge Crew, Stackhawk, Iris Risk, Teleport, Contrast, Sysdig, Trend Micro, Cloudbees, Circle CI, We Hack Purple, and Launch Darkly. And if we go in one of these rooms, let's just try it and see if they're on already. Probably not, because we're speaking, but you will see that things will opening up. And if they're on the booth, they will, well, please wait. The booth is not yet staffed, but once the talks will start, the booth will be manned by our great folks of the.
And a lot of those folks are going to have some fantastic content in their booths as well, right? So you can learn more about what they do and access some content directly in the booth. So thank you to all those folks for sponsoring. Without them, this conference wouldn't be able to happen. So thank you to all the sponsors.
Absolutely, and go into the sponsor booth as well, because yesterday I heard from Sam and Simon that they give away like very nice prices, like Nintendo Switches or other things like that. So just go there, ask questions, ask them what they're doing, like just have some chat with them, and see if there is something in it for you as well. That will be great. So I think we did the official stuff, like visiting the sponsors and the session. One thing I want to mention: if you're in a session and I showed that. Well, let me just show that again, because hey, I'm so fond of sharing my screen. It's just like doing something else. But again, if I go into the agenda and you go into a particular session, let's join the pre-event kickoff session, and let's just have some chat with them. And you see what happened there, echoing. But what you can do, you have a rating button over here, so you can rate 1 to 5 stars, and I will rate it 5 stars because
that's great feedback, Brian. Thank you very much.
Matt is so nice to me.
I think we're running out of time. For as much as I enjoyed chatting with you, Brian, I think we're out of time for our little intro piece. We'll have to pick this up again at the break. And coming up next, we've got a message from Guy Pajani, who's the founder of Sneak.
All right, see you back.
Hello, everybody, and welcome to DevSecCon, or maybe continuing your journey in DevSecCon. It's been running for 16 hours now. We're sort of now at the last third of it, and super excited now to be really kind of where I live now. I'm based in London, in Europe, and really focusing on sort of the EMEA region. If you don't know me, I am Guy Pajani. I am the founder and president of Sneak, and Sneak runs DevSecCon. We own DevSecCon, but really we run it as a community platform. And our purpose here, the reason that we invest here, is to give all of you amazing people, all of you sort of security thought leaders, people thinking about how to do security better, faster, more modern, more adapted to cloud and DevOps, give all of you a stage to share some of these learnings, share some of your insights, your hard-earned lessons with other bright people around, and that really for me is what gets me excited. I think any community of practice that we have relies on this type of collaboration. We can't just make all of our lessons, all of our mistakes on our own. We need to learn from our peers, and in security we haven't been awesome at it. As an industry, it's hard, it's scary to get up on stage and point out how you do security. You're worried about some person in the audience maybe trying to spot where you're not doing it, which makes it hard. And then if we don't do that, if we don't share, we don't get better. We really would be the best we can be if we collaborate, if we work as a group. And that was really one of the core pillars of DevOps, this idea of getting up, of sharing our failures as well as successes, and all sorts of practices and tips and tricks. And so I'm excited there was some amazing talks that you can watch as a recording already behind us. There are more amazing talks coming primarily from speakers from Europe and that region. I'm sure you'll enjoy them. I hope you find your best ones there, and I'm excited to watch them as well. What I would say is, as you watch through those, if hopefully you learn a lot from them, hopefully you take some bits and pieces that you can apply in your own surroundings. And if some of those inspire you and you think more people should learn about them, the event is free. We would encourage you to just promote them, tweet them out. The recordings would be available. Even better, if this inspires you to share your own learnings, if you want to have some idea and want to share with other practitioners something you've learned, some practice, a perspective that you have, that'll be great. And we'd love to hear from you for a future DevSecCon talk. Enjoy the final third here of the DevSecCon event. Hello, everyone. I'm Gaipo. Thanks for tuning in to my talk here at DevSecCon. Really excited to be here. And I'm going to be digging into modern security and cloud-native AppSec in a bit. So hope you enjoyed the talk. So today we're going to talk about cloud-native application security. And it's a big term, and there's all sorts of ways in which we talk about modernizing security and such at DevSecCon. But really what I'm trying to do here is I'll try to give you slightly big picture mental model and maybe iterate some key principles that we can all take kind of on the journeys as we evolve security and application security maybe into sort of this new reality. Just a couple of words about me. I am the founder and president of Sneak, which you're probably familiar with, and I also host the Security Developer Podcast, where I get a chance to talk to all sorts of smart security leaders that are, oftentimes leading the charge around this type of practices. So I learned from kind of both of those journeys. And I've actually recently written a book with O'Reilly on this notion of cloud-native AppSec, and you can get a free copy of it. You have the link over there. And hopefully, that kind of goes into deeper detail of what I'll talk about today. So let's dig in, talk a little bit about the flow here. We're going to talk first about kind of setting the stage, about the context of digital transformation, and really mostly, again, around key principles that we can take along the journey when we think about adapting security to it. We'll dig into dev-first security and how that's not just a different way of saying shift left. We'll talk about cloud-native apps and how do we secure their entire scope. And then we'll dig into some of the transformation itself. So how do we adapt? What do we need to change to deal with it? Now, this is just sort of a 30-minute talk, so we're not going to go heavily deep into each of those. But again, we'll hopefully give a bit of a mental model and some, concrete examples of sort of principles that you can try to follow as you go along. So diving in, let's start with digital transformation and adapting to it. So digital transformation is a big buzzword. It means different things to different people, but I think we'll all agree that it's real. It is a force that is happening right now in the world of technology, in the world of business, and that's the reason you hear digital transformation so often. It's because it's a very real and immediate need and focus area for a lot of businesses. And I'll talk about sort of three aspects of digital transformation and how they relate to security. The first one is that everyone wants to be a technology company. And if you work for a technology company already, for a software company, for a SaaS company, you think digital transformation, you probably are primarily focused on the next two elements about DevOps around cloud. But in many companies, in the banks, in the retailers, in really many, many different types of organizations, it's around shifting from a business that was primarily analog, was primarily in person or physical or such, into companies that really position themselves to be a digital company that does X, a digital company that does banking, a digital company that sells clothes, et cetera. And that's a significant shift. It brings with it all sort of technology investments and platform and how you build software, but predominantly it changes the center of gravity, maybe the weight that the company wants to give into their technology operations as compared to others. And with it, the center of gravity that the security aspects of that sort of digital footprint should have in comparison to the rest of the organization and kind of the practices that involves. From a security transformation perspective, what that really means is that as we go through this and we talk about principles, we talk about dev-first security and modern and cloud-native AppSec, there's oftentimes a tendency to say, hey, yeah, that's for the sort of the small and nimble SMB company that is kind of running along and moving fast. It doesn't really work for my kind of big conglomerate Fortune 100 company. And the reality is that it must, because digital transformation is trying to get all companies to operate to a degree as a technology company, as a modern company. And so as we go through these, remember that they might seem modern and fast and nimble, but really even the largest organizations are striving to work in this fashion. The second tip is around DevOps. And again, DevOps, you can write full dissertations on what DevOps is, but fundamentally, the model of DevOps revolves around independent teams. It's really around a small set of people who are able to catch the ball in one side of the court, run all the way to the other side, score, and do that again and again and again. And the tighter that loop, the faster that iteration, the better the business does. And that's important because when we think about security, we should use that as a guiding factor. We should assess any solution that we try to devise for security on its ability to sort of fit this model, to have application teams that are building it be able to apply that security model, that security process, that security tool independently. And really, fundamentally, if they cannot, it won't work. It would go against the grain of every company wanting to be a technology company. This is especially important for security, which has a natural tendency of being much more centralized. And so thinking about it in this independent teams model is something that is a great, significant principle to keep in mind as you transform. And then the third element of digital transformation I'll highlight is the notion of cloud. And, again, words can be said, but fundamentally, cloud changes the scope of the application. In the pre-cloud era, an app was mostly some code and some libraries, and they were sitting on top of a big central IT stack that was centrally managed and provided databases and servers and networks and data centers. In cloud, these things have not just become virtual, they've become APIs. And they are invoked and managed through the repository. They're sort of naturally a part of the software development process. They are stored in some repo, they're applied through a build. And so they've become a part of the app, or rather the app has grown in scope to encompass these aspects. And so when we think about this, for security and for application security, it means we need to expand the scope of application security, because all the security concerns, all the decisions that these IT people were making about that sort of central stack to try and avoid unpatched servers, try and avoid misconfigured infrastructure, all of those have moved to become APIs, and those decisions are now being made by developers as part of their kind of repository and the files in there. And so we need to shift, and we need to think about application security in a broader scope that now encompasses these sort of full stack. So fundamentally, all of those combine into a need for a new approach to application security. It's still application security. We're still securing the app. That's what we're doing here. But we need to grow the scope to be cloud native application security, to include the full scope of cloud native apps. And we need to make it dev first to be able to adapt to these sort of independent team approach. So what does this mean? Let's sort of dig into two of those elements, the dev first and the cloud native. Start with dev first. So what's the difference? What's the meaning of applying security in dev first fashion versus not? Before I dig into sort of specific examples, what I would say is the secret is in the name. Developer first security implies that you should start by asking, if I am a developer and I want to tackle a security risk, what is the optimal solution for me? Forget everything else. Forget all the other needs. Forget your own need if you're a security person, your own needs, and just say, what is the most important? What are sort of the attributes that are most important in the solution for a developer to be successful, and then build from there. That's the meaning of developer first. You first start with the developer's needs. So with that general philosophy, let me give you maybe 3 concrete tips that we can try to apply here. First is, what does a developer know and what does an auditor know? So kind of this context of developer versus auditor. And at a high level, developers understand the app. They know the app far better than the auditor does. They live and breathe the app. They've built parts of the app. They understand the functionality. While an auditor, they understand the risk. They've seen this attack. They've seen this vulnerability many a time. They understand what can happen with it. And that's the context. That's the world in which they approach the same bit of information, or they judge the same bit of information through. And the other way to think about it is, with that knowledge, when they zoom out, they see different things. When a developer zooms out, they have a security aspect of their application, and they zoom out, they see the application. They see the application with all its glory, all its moving parts, all of its performance issues, all of its resilience issues, all of its quality bugs. That's what they see. They understand it, and that's the lens through which they see the security problem as another aspect of the application. Well, for an auditor, when they zoom out, they see the whole risk. For this app, they see all the bad things, all the assets can be stolen. But actually, more often, they don't really think about just the app, because most auditors are not just looking at one app, they're looking across a portfolio. And so what they see is they see the same risk, the same cross-site scripting, or the same known vulnerability across apps. And this lens is very, very important. When you look at security solutions today, they heavily bias in favor of the auditor product. They tend to default to showing you a vulnerability amidst a list of vulnerabilities. That's the zoom out. It's all the vulnerabilities from all the apps. Now you can kind of drill into them. They tend to just emphasize, in terms of the elements and the information provided, the risk that vulnerability or that sort of security defect represents. While for a developer, those are fine. They might cope with this, but that's not their primary lens. Their primary lens really is the application itself. So what they're seeking is, when they want more context, is how does this vulnerability relate to my application? Where does it sit in my application? And they might bias more towards trees of libraries. You sort of use this library, use that other library, use that other library. That last one is vulnerable. Great. Now I know how it got into my system. And there are many examples of it. So when you think about developer-first security, you want to present solutions in a way that first and foremost highlights the place of that security issue within the application. The second, and this might come as a surprise, is that developers like developer tools. Generally, your security solution, my security solution, any security solution, it's not the only thing that the developer is using. In fact, far from it. They are using a myriad of tools, dozens, sometimes more tools in their daily lives. And those tools have an affinity. They work in a certain way. They are built in a whole methodology around being self-serve and easy to use. They have certain UX. They do that sort of application context we talked about before. They adhere to some common guidelines around kind of the developer experience, the DX versus UX, or as an aspect of UX. And on top of all of those, they relate to one another. They talk about contexts like a LAMP stack or many others. And so when you think about your solution and you think about a developer-first approach, and again, it doesn't really matter if it's a homegrown solution or something commercial or anything else, you want to walk and talk and quack like a developer tool. You want to model your solution on other solutions that the developers might be using. And that in turn would make it natural for a developer to use it. If you are building it, if you're modeling it like the vast majority of security solutions out there on an auditing tool, and you just try to shift it left to kind of plop it into the pipeline or into a repo or IDE, it's not going to feel natural for developers. Now, what I have here is a bit of a visual, which is everything I described right now sounds like I'm referring to just the product itself, the tech, the UX of the product. But in practice, when you think about developer tools, you should think holistically, especially if you're building a solution for a security solution for developers. You have to think about the go-to-market. Developers like to use before they buy. They like to start self-serve. And then when they see success, they like to grow and scale that. While security solutions tend to be much more sort of top-down, find some buyer and then roll it out across it. Developers like to start small and try it, and then with proven success grow, while security solutions tend to start in a centralized fashion and roll it out. And so if you want developers to embrace your solution, whether it's developers in your company or it is a solution that you're building, you want to think about developer tools. You want to model after developer tools. And this is a screenshot from the OpenView Dev Tooling GTM playbook, which is a great read that I recommend. And I actually just set this tooltip over here. And then the third and very, very important bit to remember is that security people audit and developers fix. And that's a very, very significant distinction. It's not a statement to the detriment of either party. An auditor's job primarily is to make us aware, make the company aware, make the developers aware of the security flaws in there and that are in the systems they're building, to provide platforms to help them find those issues, and then to ensure that those are logged and prioritized and captured in the right fashion. But a developer's job isn't those. Yes, they also need to find issues and they need to run it, but their primary job is to fix them. Their primary job is not to be aware of bugs. Their primary job is to fix the bugs. So there's a whole set of steps that go from a logged issue to a fixed issue. That's true security or otherwise. And it's amazing how many security solutions are out there, again, homegrown or commercial, that even state when they talk about fix, there's fix button, there's a remediation section where the remediation is logging a Jira ticket. Logging a Jira ticket is very important. It is not remediation. It is just that. It's logging a Jira ticket. It's logging a ticket instead of in a separate system in the development team system, which is better, but not sufficient. And so you want to think the whole journey, think through the whole journey in the homegrown or in the practice or in the process or in the commercial tools you're building. Think about how do you bring it all the way to actually fixing the problem, to actually helping a developer fix the problem. So all of those combine into a more meta perspective, which is when we think about dev for security, we need to remember that our goal isn't to shift left, as you see on the left of the screen here, somewhat ironically, isn't really around shift left, which is that's a great practice to shift left. It came from the waterfall practice. I was saying shift left back in 2002 when I was building kind of AppScan and AppShield back then, and the notion of shifting left is an efficiency play. It's around don't find the issues after you've deployed. Find them early, find them as you design them, as you build them, as you code review them. And it's great, and it is indeed more efficient, but it's just not enough. Shifting left, taking the same audit you would have run late and running it early is really only a small piece of the problem, and it's not at all DevOps minded. It's just an efficiency play. The real change that we want is one of top to bottom. Today, development process is continuous. These teams need to own their entire journey. So they own the stuff that happens on the right and the stuff that happens on the left. And really what you want them to do is you want them to own the security aspect of that journey successfully. And you want them to do that on the left, and you want them to do that on the right. And ideally, you want them to decide when is the right time for them to run it, because you want them to own the risk, equipped with the right solutions to be able to address it. And so keep it in mind, shift left is great, but really the primary goal for this exercise is an ownership change. It's a top to bottom from a dictatorial sort of centralized security team that makes the decisions for everybody else to more of a democratized model in which these development teams are able to run with the right tools, with the right governance. They still need to be kind of monitored and tracked, but they need to be able to operate that security and make good judgment with sound judgment calls and build secure things on their own. So with that, let's talk about cloud. All of this was really dev for security. And you can say dev for security is adapting security to DevOps. Fundamentally, it's around adapting security to this model of independent teams. And those independent teams happen to be primarily developers, application developers. Cloud, as we talked about, requires us to sort of rethink a bunch of these IT security solutions into application security. So let's dig a bit more. As before, rethinking IT security into application security is not something I'm going to cover in sort of 5 minutes here for you. You have to dig deeper. Hopefully the book gives you a bit more information, but still there's more. It's more of a meta concept. But if I was to sort of give you 3 core anchors, the first element to it is to remember that your infrastructure is in your repo. So this statement today, you have a repository, it has the full stack, everything around it sits in that repository. Sometimes it's a neighboring repository, but your code, your open source manifest, and your container configuration, and your Helm charts, and oftentimes Terraform files, all of these things, they sit in the repository. What this means is that you have to rethink or start by thinking about tooling that work in the context of a repo, a pipeline. These are constraints and an advantage. So you want to think about where do you run your test? You should run it where possible, more like other application security solutions. So can you find a cloud security problem or a container security problem in the IDE? Can you find it when something got created in the repo? Can you find it in the build? The builds people are a bit more familiar with, but can you think about the fact that your infrastructure is in the repo? It means you will be well rewarded if you build solutions, if you build something that can actually find those problems when they are in the repo, when they are in development, local development, because that is that sort of shift left, that is that early detection versus finding it late. So you have to rethink, how do you secure an aspect of infrastructure when it was still the code that leads to that infrastructure? And by saying infrastructure, I mean all these layers that are below code here. And I think I'll to kind of try and bring it home, I'll give two examples, one for container security and one for infrastructure as code, of how you could do this. So for example, for container security, a good example of it is separating out base image. When you try to rethink container security from a dev first angle, you can say that the distinction in how the base image is managed is very, very big. From an auditor perspective, the base image doesn't really matter. You have a container image, it has a bunch of files in it. Some of those are vulnerable artifacts. You audit the image, you find a bunch of vulnerabilities, and that's kind of the end of the story. You found a vulnerability, you go off to assess the risk. That's the risk mentality. I don't really care where it came from. I care that the vulnerability is there. For a developer, it's night and day, whether a vulnerability came from a base image or whether it came from the Docker file. To an extent, if it's in the base image, it's an upgrade exercise. Okay, I need to take the newer version of the base image or swap it. If it's in the Docker file, it's in my code. I actually created it over there. There's a code change that I need to do. So that's sort of one example of rethinking container security into dev first. Again, one of many. Another example is in infrastructure as code. Skipping slide here. So in infrastructure as code, you can think about what is the continuation of the information you provide. So say you scanned a Terraform file and you found a vulnerability. You found kind of some mistake. You've done it well. You've done it in the repo or in the pipeline. If you're a developer, the next question is, where is this in my app? Like, which functionality does it touch? So that I would know if I make this stricter, if I change the user, if I do that, would I break the app? From an auditor perspective, you go down a very different route. You go down the route of risk. You go down the route of saying, okay, so I have this. Like, does it matter which data assets are exposed? Should I ring the alarm bell? Both are legitimate perspectives, but they are very, very different. So you want to think about your solution and where does it guide the developer? If you gave a developer the auditor perspective, they will not be successful. So this is probably a good point to say, I'm not dissing the security perspective. Security people are critical to all of our success. You know, some of my best friends are security people. You know, it's super, super critical to keep the organization secure, that you have that risk perspective. All I'm saying is it's not going to get you developer adoption. So the mistake happens when you build an auditor tool and you give it to developers and you expect them to successfully use it. That's the piece that I'm saying would not happen. So we just went through, you know, the kind of the general kind of pillars of digital transformation. We talked about developer first security and how to sort of maybe some tips around how do you adapt to it. Talk about cloud native AppSec and how do you want to sort of rethink some of these IT security controls as a dev first application security approach. Maybe just before we wrap up, 2 or 3 items about how do you adapt a little bit more broadly as an organization into this world, right? How do you rethink AppSec into seen as a security org? What should you consider? So the first thing to consider is the security organization itself. When you envision this reality in which developers own a lot of security, that means the job of the security person is different. It means, if I look at the right, that they are no longer meant to audit. You know, it's not the security team's job to find vulnerabilities and to, you know, log them and to do all of that, because that won't scale. That's precisely what we've been doing and have been in this independent team model running into a blocker. What you need is that same team to build solutions, to provide, whether they bought or they built, doesn't really matter, to provide solutions to the developers so the developers can do those audits themselves as a natural part of their development process, so they can find those vulnerabilities. So it means within the team, you're going to need less auditing skills and more engineering skills, more platform building skills. This is very similar to the SRE type shift that has happened, where you're not the one on call. Sometimes you are, but that's not your primary job. Your primary job is to help developers build an operable system. And on the left, is really more around that cloud native aspect, is you want to rethink the scope of the team. We have this newer team over the last sort of 10 or so, 5 to 10 years, titled cloud security. And cloud security, it has a bit of a built-in identity crisis to it. On one aspect, it is the evolution of IT security. It's the evolution of securing your data center. Now you're securing the thing that's in the cloud, as well as some of its cloud-specific attributes. On the other side, you have all of these aspects of infrastructure that have moved into the app, and they need to be application security minded. And so it's a tricky proposition. The industry hasn't quite decided where it is. But my advice would be to think about expanding the scope of your application security team, which has historically been deemed more, your code and your libraries, maybe sort of securing those, to more of a product security team. And that includes the full set of products, whatever that includes. It includes a bunch of these layers. It includes security features. That view should help you, first of all, centralize and think about those IT security aspects as parts of the app, or infrastructure security aspects as part of the app, but also it would help you empathize and be closer in your perspective to the engineering teams that you are supporting. The second thing is to rethink priorities. So most AppSec programs start from some, SAST, IS, DAST, type, 4-letter combo. And when you stop to think about it, the vast majority of those is to find vulnerabilities in your code. And that's okay, that's legit, because up until not that long ago, that was the primary job of developers. So AppSec was primarily about vulnerabilities in your code. As we just discussed, that is no longer the case. Now there's a broader scope. So you want to pause and think, given the full scope of cloud native AppSec, which threats am I most likely to be breached by? Is it more likely that I'll be breached by a vulnerability in my custom code, or by an insecure piece of infrastructure, right? Or an unpatched vulnerability or unpatched library? So the decisions would be yours and they vary. But what I would say is pause, think about the full scope. Now it's going to be the same developers, the same dev time going to fix a container security vulnerability will come at the expense of fixing a code vulnerability and vice versa. And so you want to think about your priorities a bit more holistically. And then last, and this is after you've formed your perspective and you've formed your structure, you want to rethink the tooling. And I've already kind of harped on a bunch of this, so I don't want to boil the ocean too much here, but I would say first, think about tools in the context of developer tools and judge whatever solution you're building or buying towards that effect. Second is think about the platform scope. Yes, you can look for if you're looking for a platform, if you want to minimize vendors, you can look for a platform that has the classic DAST, all the sort of AST acronyms in it. But I would say you'd be well served by thinking about the full scope of everything you want your developers to deal with, and think about a platform that supports that full scope. And then the third, and it's more subtle, and you're going to have to make a judgment call, is to say, look at the solutions you're building or buying and say, what's the governance approach that they support? Are they focusing on, hey, you're a security person, you found a vulnerability, how do you then communicate it back to your developers? Or do they focus on, hey, you're a security person, how can you help your developers find those issues themselves and deal with them themselves? And how do you govern their activity? And of course, subsequently, how does the system help those developers handle those security concerns? And so just pause and think about tools, not based on the old models, but rather based on the new scope and the new approach you're hopefully embracing. So that's basically it for me, right? We talked about security transformation to match digital transformation. It's a must for everybody because everybody's undergoing digital transformation, and every large company wants to be able to work, to have independent development teams work as nimbly as that sort of new scrappy startup. And those independent teams, they require dev-first security solutions. We have to think about our solutions in a different fashion. You want to make sure that you apply AppSec to the full cloud-native AppSec scope, including those previously IT layers, and you want to rethink your organization, your security org, your priorities, and your tooling to match this world. And if you do all of those well, you get a chance to profit. You get a chance to be better than the competition, and you get a chance for security to be an enabler, for security to benefit the way DevOps did from a more builder mentality, from a more builder appreciation in your organization, and be seen as something that helps the organization thrive versus just managing some side risk. So good luck.
All right, again, good morning, everyone, and welcome to the session on API security as code. My name is Isabel. I'm one of the co-founders and the field CTO at 42Crunch, which is a company doing API security, as you may guess. And here is my Twitter if you want to contact me. So what is this presentation about? Basically, as you probably know, I'm sure you've seen the news, there's a lot of problems around APIs right now. The number of breaches has been going through the roof in the past 2 or 3 years. And if you're following API Security.io, which is one of the your community sites that we have at 42Crunch, where we report and educate on all this kind of problems, you'll see, very well-known brands like the one you see here on the right being hit by such problems. And if we analyze those, we'll see that there's pretty much a number of problems that always happen. And it's the combination of multiple things that make it, in general, when there is a very large breach, it's never because people have one problem, it's because they have a combination of problems. And those problems will be authorization problems, data validation problems. We still are not very good at validating the data coming our way. We trust the information coming our way, or the other way around, we're leaking information that we should not be leaking, or we have rate limiting problems. And just to illustrate that, I just took one example, which for me, it is the really example of the year, and show you what type of problems they have. Now, what are those problems? We have classified those problems in an OWASP top 10 recently to recognize the fact that indeed there are lots of problems, and there are not the same problems that we have with traditional applications. And the OWASP came up with a brand new list just focused on APIs, right? And basically there's 3 groups of problems there: authentication, authorization, again, data control, and configuration issues. So let's take this one example, which is Parler. So you may have heard about Parler. This is something like a social network like equivalent, and that came quite famous with all the Trump administration and all the problems that came around it. And became even more, famous because of this API issue. As you can see here on the right, I have a whole presentation on many different issues, and what I do is reference what kind of problems they got according to that top 10 list that I just showed. And it's probably the first one that I see that has a 6 out of 10. So what happened there, right? So this is a huge breach. We're talking about 70 terabytes of user data. And what happened? This is really the epitome of what you really, really should not do when you are exposing an API. First of all, this is completely open, no authentication to access any of the posts, which is a social network, that people are doing. So if you have access to the API, you have access to all the data. 0 rate limiting, which means if you write a little engine, then you can go and retrieve all the information. And to make that easier, all the IDs of the information is sequential. That means, like, if I'm doing a post, it's post number 1. If someone else is doing a post, it's going to be number 2, number 3, etc. So it's very easy, again, to write a little engine to go and retrieve the information. And of course, if there is no rate limiting, then as you can imagine, there's nothing stopping me from retrieving, well, a lot of data, 70 terabytes. Lots of information which is really sensitive in there, which touches on API 3 and data leakage that I was talking about before. And maybe the best one, really bad ones, you were deleting information. So I guess, after all the politics and what happened, a lot of people wanted to delete some of their posts, right? But what was happening is, behind the scenes, this would not delete the data. It would just hide it from the UI. So the data was still there, accessible in the backend through the API, which basically meant you didn't delete it at all, right? So this is really a very, very bad example of what you must basically must not do, right? Now, why is this happening? So this is an extreme example again, but there's tons of them. Well, the first thing is, APIs have changed the way we have architected our applications. We used to have architectures whereby on the server side, I would have all the logic, or like a controller layer. The data would be protected by that controller layer, and I would just expose to the client side, HTML and JavaScript, basically. So the logic will not be on the client, it will be on the server. But now what we're doing is we have the same data, we're exposing it through APIs as raw data, and we count on the client side to massage that data, assemble it, and expose it, right? Forgetting that, that controlling obviously will never happen. Whatever you're doing to filter the data or anything at the client side obviously is not there, and nothing will happen if I go straight into the API and into the raw data. So other people are counting on the fact that, the client side is going to do a lot of what the server side would be doing. But if I go thread to the API, then none of this is basically happening, right? So that's one of the main problem, which is basically the new architecture. The second one is because we're dealing with data and APIs, the way we're doing application security is basically has to change as well. Because what we used to do is to build walls around our information, right? So we'll go and protect the perimeter around our company, but there's no more perimeter. This is gone, because every time you open an API, what you do is you pinch a hole in that perimeter, and you open avenues. So you have this image of the Arc de Triomphe here in Paris, where everything goes into that center. But every time I open API, there's a new avenue to that center. So what we need to protect is not so much the borders anymore. We need to protect that data and making sure that, we only expose that data to, whoever is supposed to consume it and nothing more. So it's all about protecting data now. And to make it worse, right? Well, we know that, right? We're pretty bad at thinking about security early in the API lifecycle. We tend to wait very late in the lifecycle, if any. I'm talking to a lot of prospects as part of my job. They're telling me, I know, Isabel, I have tons of APIs, and I know some of them are going to go all the way to production and in production, and I know they have problems. But because we took on this job of fixing them, even testing them so late, I don't have the time to fix them, and I cannot block production and the release of those APIs, which have a big business impact, because maybe there is a problem and I can't prove it, basically. So it's really important that, we don't do that. We have that problem. Now, what else is wrong is we have really given the developers fantastic tools for being very productive and write APIs, like, as some AppSec people tell me sometimes, those things are popping up like mushrooms all over the place, and I have zero control over them. And one day there's 20, and the next day there's 50, and the next week there's 100. So how can we do security in those conditions? So first of all, not only do we start late, but on the top of that, there's tons of those, and they change all the time, because we are automated all the development, we have automated the deployment. So it's very easy for a developer to create something new in a matter of days, right? So we really have to equip our security people with better tools here. So plan of action. How do you make sure that we don't do this? Like, how do we address that problem? And for me, it's threefold, right? First of all, as we were just saying now, we really, really have to consider security way earlier than we were doing now, right? So as early as I would say as design time, when we're thinking about what this API is going to be, there's some things we need to think about there, and we need to consider there already, right? Then we need to really embed security into the API lifecycle. So the main problem that I hear about when we talk to developers, for example, is they say, okay, I want to do security, but I have a timeline, I have deadlines to respect. So anything that you ask me to add in there that's going to impact my productivity, that is not going to work for me, right? It needs to be something which is embedded, which is transparent, and then I will use it, but not this like complex stuff that I have to do. That doesn't work for me, right? So we have to embed security in lifecycle, but in a way that is, compatible with the productivity requirements that the development teams have, right? And the third one is we really need to put ourselves in the head of the people that will do all this hacking and start looking at things not from so much a defending point of view, but from an attacking point of view, right? So we need to start hacking ourselves, fuzz ourselves, so that we don't expect somebody else to actually do that. We're actually doing that ourselves, and we do it in a continuous fashion. So every time we make changes to the API, we discover if we have, by bad luck or bad design or whatever it is, introduced some new vulnerabilities and problems, right? So let's talk about design time first, right? So design time decisions for anything, this is a good example, are very hard to undo. If you have started designing something, you have all the blueprints, and think of this, this is a good analogy because for design, a lot of people talking about houses, right? So if you've not designed properly the blueprints of where you're going to put the doors and the windows and such arrangements in your house, once it's built, it's going to be really hard to undo. Well, the same applies for APIs. So what do we have to do? There's tons of decisions we have to make when we start working and designing APIs. So the first thing is you really have to know what it is that you're building. Security is all about risk. So, okay, I'm going to open an API for Woo. Is it something for an internal application? Is it for an external application? Is it for partners? Is it something we're going to open only to a specific set of people, like administrators, for example? So who is going to consume this data? Then what is the data we're going to expose? So is that data sensitive? Like, do we have some personal identifier information in there? Is it financial data? Is it healthcare? Is it, whatever? We need to know what the data it is that you're manipulating, right? For example, and then if it's very sensitive data, maybe we need to sign or encrypt that information. This is very common in, banking, healthcare, insurance now, where we are transporting information that potentially is very sensitive. So think you have to remember that even if you're using an encrypted channel like HTTPS, for example, once you are at the end of that channel and it stops, that data you have been transporting isn't clear. So when TLS ends, the data isn't clear. Is that okay? Is that not okay? So do I have to encrypt that information? Do I have to make sure that nobody can change that information on flight, which would require signing, right? So we need to know about that. You need to really spend the time to sit down with the business, with everyone, and design this properly. Understand, if you want, look at this as like a threat model around your API, right? Okay, so now we know what we are going to do. We probably know if this is a risky thing we're doing, what is the level of risk. And then from there, we can define the security. Different security is depending on the risk, right? So now we're going to expose, okay, what are we exposing to who? So who has access to that information? And this is where I'm going to match this to API 1, 2, 3, all the way to 10, right? So at that level, so my point is really, it's already there that you're going to take some decisions which are affecting this OWASP top 10. Again, there's some things in there, once you have decided to do things in a certain way, it will be very hard to undo. Let me take a second point here, which is a very good example. So our resource IDs exposure. So this is this API 1. API 1 is like the top, as it says, the first problem that people have with APIs today, which is basically allowing someone to do this iteration. So let's say I have an API that allows me to see my bank account. Okay, so I'm connecting to this API, I'm putting my access token and this is identified as Isabel, and I'm accessing bank account 123, right? Now, if I'm trying to access bank account 124, which belongs to Guy, right, then I should not be able to do that because I'm not the owner of that specific resource, right? So you have to know about what those IDs are and eliminate maybe the risk of not putting 123, for example, of my URL, but putting /me or /my account. So I don't have a number in there. Again, as you can see, this is the design of the API. Very important, designing the data. What is the data we're going to expose? What is the data we're going to accept coming in? What is the data we accept to return? So make sure we don't take data in that we're not supposed to take in. This is something called API 6, which is mass assignment, basically allowing data to come in that we're not supposed to, or the other way around, accepting, well, actually API 8 is one of this, which is injections, the infamous SQL injections, NoSQL injections. All of that could be eliminated if we knew exactly, this is the data that comes in with all its constraints, this is data that comes out with all its constraints, and anything that is not matching that will not be accepted as input and outputs, right? A lot of problems could be eliminated if we were doing this. And then making sure, I see a lot of people doing this, sometimes for APIs, we need admin operations, like some behind the scenes operation, manage users or manage accounts across the board. Usually you don't want to mix those two things. A lot of people are putting that into the same API, and then we forget about putting access control, and then everybody has access to admin. So again, this is a design decision. What are we going to need? Where does the operations will be? How we can access those, right? And even there at design time, you need to start about operating that API. You're going to expose it. You're going to deploy it, right? Login, monitoring, very important. You need to know how this API is going to be, operated. Where will I see the logs? What is in the logs? Is there any sensitive data that we want to make sure we are not writing the logs? Make sure it's not there. How we will monitor how effective our API is, how we will enforce rate limiting and make sure people cannot abuse the operations of our API, how we will manage the versions. So create a new version, retire the old one. All of that are design decisions. Many of these we will not be able to change again if we realize we have a problem like the day before releasing the API. It will be very difficult. So you have to ask yourself all those questions. Now, how do we formalize that, right? Well, we're very lucky in the API world to have standard languages for defining what an API does and basically defining most of the requirements that I just mentioned. And this will allow us to take an API design first approach, by which I first define this interface of what, that's the contract, that I'm the API producer and I'm exposing an API. That's the contract that I'm taking, that this is what my API will do. This is the data I will expose again, etc. That's how you interact with my API. And then from there, you can create implementation, you can do automated testing. Of course, you can do documentation, which is the primary reason OpenAPI was created many years ago, but now is serving much more purposes, right? And my proposal here in this talk is also to use this as something I call security as code, right? It allows us to enable this approach called security as code. So what is security as code? If you think about what Kubernetes brought us, right? For example, it brought us infrastructure code, things like Terraform and Chef and Ansible. What they allow us to do is to describe our architecture in a static way so that we can have repeated processes, we can version this, and we'll know if we have a script that has been executed with this information and we run it again and again and again, we'll always end up with the same architecture being deployed. So same thing if you apply the same principles for security. The idea is you express the constraints of security within that static file so that you can, again, track the changes. We have something which is transparent, everybody can see, we can automatically analyze it, right? And it enables an approach in security, which is very important, called positive security model. So what is that? Right? Basically, in security today, you have two ways of looking at things. The traditional way, I would say, some tools like web application firewalls typically do is to take a negative security model. What does that mean? That means that basically we let everyone go in, right? And then we have some patterns, very much if I can make a parallel with antivirus, right? You probably, I hope, all have an antivirus on your machines. And regularly, this antivirus has to go maybe every day or maybe every hour and refresh its database of known viruses, right? So that it can look at all the data coming on your computer and matches that against the database and say, yep, I recognize this as being something bad, so I'm going to block it. That's really a negative security model. So it's all based on the fact that you have a well-known list of threats that you can recognize through signatures and patterns, and then everything that goes your way, you're going to compare it against that list of threats, okay? So it's very threat-centric. Now, a positive security model works the other way around, which is the door is closed to everyone but people who are on the allow list, right? So this is really about knowing exactly what's going to hit you in terms of traffic and say, yeah, I know exactly the traffic which is going to hit me. I have a list. So whatever is not on that list basically cannot go through. So it's not so much focused on knowing what are the bad threats that can come your way, but rather focusing on making sure and knowing of all the things that you want to accept. So, in an API world, this open API or async API, that's exactly what they do. They describe, this is my API, that's what it does, this is all data that comes in, this is all data that comes out. So I can use that as a positive security model for APIs so that I can decide to reject anything that is not described in there. I also have authentication authorization descriptions in there. So I'll know exactly who I'm going to accept or not, right? And then we can focus the security and everyone within that full flow all the way from design to production in ensuring at testing time, at design time, that this allow list is as precise, as good, and up to date as possible, right? That's kind of the idea. So that we can then use the different parts of the Open API to enforce, what is the security that we're going to apply to this API? I know because Open API allows me to describe that. What is the data, parameters, data formats? So, and then we have some additional things which are coming into Open API. I'm part of the Open API initiative. So we're working also on SLA to allow you to describe rate limiting in there and SLAs, as well as those signatures and encryption I was talking about at the beginning, and also workflows. So that you can decide, well, to use this API, first you have to call operation A, then you have to call operation B, then you have to call operation C. You cannot consume the operation described in the API in any order that you want, right? So that will also give us another level of governance in terms and control over how the API is actually used. And if I have all this information and I can do a lot of things, I can automate a lot of stuff. I can automate the validation of that Open API or async API file. I can do automated security testing. I have governance because now I know exactly what is the API that I have, how is it secured. I also have data governance. So this is the data that flows through my API and is controlled through that file. And anything that is not that will actually be, rejected. That's kind of the idea, right? Now, the approach I would like, to propose to you, and ideally, you should be able to do, starting with an Open API definition, maybe with some extensions to describe the extra security and rate limiting, etc. I was talking about, is I'm a developer. As we said at the beginning, for developers, this all needs to be transparent and easy, right? So I'm a developer, I'm in my development environment, I'm working on my code, I'm working on my Open API file, I commit this to a code repository, or maybe GitHub, Bitbucket, whatever it is, And then this starts an automated process. And as part of that automated process, I'm going to look at that Open API file, what it has, what is the security in there? Is that the security which is required by the company, for example? I can do automated testing with the tools I'm going to talk about right now. I can automatically attach some security policies which are governed by my company. And I can automatically deploy the protection in place, the security policies, which are derived from my Open API. That's really the vision, is to, rather than doing, manual enforcement and rules around security, which are always a problem because people forget about them, they don't put them in place, we cannot test if those are in place or not. If you drive this from the definition of the API, then everything can come out of it, right? So this is really a movement that we see. This is something we've adopted at 42Crunch, but also we see more companies doing this because I think it makes sense, because we have really this ability to know exactly what the traffic is going to be. And if you can express that in text form, right, then you can do a lot of automation and a lot of analysis on top of that. And that gives you this continuous, virtuous circle of deploying a new API, creating a new API. I can have 10 a day, I can have 1,000 a day. My CI/CD pipeline doesn't get tired. It will take it and execute it. So it's not like I have an AppSec person who is overloaded with work at the end of a pipeline and has to say, this is a new API, go test it, right? So as much as we can do that is automated as the core of the testing and enforcement, then the more we can do all this in an automated way, the better we are, right? So what do we have at our disposal here today? We have, we have a tool the first thing to really test here is the Open API file itself, or the async API file itself. So how good it is, because one of the key things about a positive security model is that it's very important that that description, obviously, is of good quality and reflects what the API actually does, right? And has all the constraints and requirements, again, on the data formats, on the security, etc. So you have a tool, we have an online version you can try for free here on APISecure.io if you want to go and test it. That will give you this report on how good your Open API file is, right? And then from there, you can do some fuzzing, for example, from security testing, see how the implementation of your API actually is, how resilient it is and how it works. This could be something like ZAP, which is an OWASP project. Staghawk, which is a product that's actually based on OWASP ZAP. It can be Wrestler, which is a project from Microsoft. All of these are in the references if you want to have a look after and test them yourselves, right? So what those tools will do is they will consume the Open API. They will create like a graph, if you want, of all the things they have to go and test, and they will do this automatically. This can be put inside your CI/CD pipeline. So it happens every time you actually change some code, right? IDOR, as I said, BOLA, which is API 1. This is a very important, again, API 1, top of the API top 10 list. So Yelps has open sourced a project which is very interesting. It's called FuzzLighter. And what this allows you to do is to, again, you can take an Open API file as input, and it will automatically go and find all those IDs. You can enrich it with your own testing. So you can, again, automatically test for those IDOR, those indirect references, this API 1 type of issues. And this is really a great project for doing this kind of testing automatically, which, again, is a huge problem in APIs today. And then, so we're also doing something very complementary on the 42Crunch side, which is more about testing the constraints on the data formats, etc., from the Open API files, just to make sure that at any point in time, your implementation of your API is in line with the definition you're making. So you're not making a change in the backend that is not reflected inside the contract. On the contrary, you don't have things in the contract which have not been define, for example. So you could have some error conditions that you forgot to put inside the contract, or there are things in the contract that have been changed and need to be changed in implementation. But anyway, the whole idea is, from a governance point of view, what you want to make sure is at any point in time, what the contract says, again, this is what my API is doing, and the implementation of that are in line. And you can hammer and friends your API as much as you want. It will always answer as per the contract. That is really the idea, right? So my call to action for you is really to do this shift left movement, which is to really look at security as early as possible. And if cost is an issue, which usually it is well proven that it's very, very hard. As I said, any design decision is very difficult to fix. So if you made a bad design decision, on the contrary, you haven't even looked at what the decision should be, adding this after the fact, it is very costly. And finding all those problems from a security standpoint very late in the life cycle is very expensive to fix. So the earlier you address those, the easier it's going to be to do technically, and the less expensive it's going to be, right? Now, hack yourselves. We said that you have to hack yourself. So this is all this testing that I was talking about. Usually what I see people doing is testing the what I call the happy path, right? So it's like, if I put some right data, the API is basically working. Maybe is a bit of testing of some data is not right. Like the token is wrong, then we should not answer. That's usually being thought of. But really what you want to do is at every stage, every time you change an API, you have to hammer your API with bad data, bad formats, bad users, bad tokens. Anything that can basically happen is actually something you want to test every time you make a change, because every time you make a change, you have the opportunity to do something wrong and introduce a new problem. So that's another big message. Security is not a one-time off. It's not like you test something in July, right? And you don't look at it again until September. That doesn't work this way, because in between those two things, all you get is a snapshot. And zillions of things could have changed between those two dates, right? So that's why it's so important that you do this every time something is changing. It has to be part of your pipeline, right? So it's very critical to automate security. Don't rely on manual testing every X and Y. Of course, you can do manual testing with pen testing regularly. You're not going to do a pen test every time you change 3 lines of code in your API. Of course not. And for a cost, because of the cost you will have at many different levels. But this automated testing, if everyone was doing this, like API Security IO will have much less entries. That's kind of what we want, right? So our goal is, at 42 Crunch and in the industry in general, is just to make sure you really shift left, do all this automatically as much as possible, so we have much better APIs, much more secure APIs, and more work and less work, I would say, for all the actors around there. All right, and those are the references of the things that I've been talking about, and I'll thank you for your time today. I encourage you to go and see API Security.io that we are curating. Subscribe to the newsletter. There's a lot to learn about all those practices and about breaches. It's always good to learn from other people's mistakes. And we'll be now taking some questions through the Q&A. Thank you for your attention.
Hello, everyone, and welcome to the third and final keynote panel, which is the EMEA keynote panel. And today we're going to be talking about the topics of measuring and DevSecOps maturity. So joining me on this panel today, we have Alyssa Miller from S&P Global. We have Tash Norris from Moonpig, and we also have Patrick Dubois from Sneak. So I'll ask each individually actually to introduce yourselves, tell us a little bit about yourselves and your respective organizations. So why don't we start with Alyssa?
Sure. So, hey, everybody, I am Alyssa Miller, former developer, longtime security professional. As Simon mentioned, I'm currently the Business Information Security Officer for S&P Global Ratings. So some of you may remember back to the days of Standard & Poor's, same company, same deal. So just really excited to be here.
Awesome. Welcome, Alyssa. And over to Tash.
Hi, everyone. Yeah, my name's Tash. I'm a recovering solutions architect and security person. Still occasionally draw diagrams if you let me loose anywhere with a whiteboard or a pen. I just can't help myself. And I am currently head of cybersecurity for Moonbig.
Awesome. Welcome, Tash. And finally, but by no means least, Patrick.
Yes, I'm Patrick. I would say I'm a DevOps enthusiast, and by extension, I am a DevSecOps enthusiast. About 10 years ago, I, by accident started the first DevOps days, and I've been following DevOps ever since. I've done many roles from developer, manager, system tester, CI, you kind of name it, and I've run it over the years. That's why I have the gray hairs. And yeah, kind of figuring out how we can collaborate better together. And currently I'm at Sneak figuring out how security comes into the fold. So.
Awesome. And people call you the father of Java, not father of Java, sorry, the father of DevOps, right?
Well, that too, but
did you this is a pre-recorded session, but did you get a Father's Day card from DevOps yesterday, Patrick?
No, so it isn't the father. They say it's the Godfather, but
the Godfather.
Like, okay. But it's not like in the mafia film movies. it's just like I'm being nice to them all the time.
Nice.
So that's why they call me like that.
Excellent. Well, what a great panel we have today. This is a great set of humans and people on the panel. So excellent to have you all together. And let's kick off this session. Why don't we take it back to scratch and talk about companies that are just beginning their journey into DevSecOps. And Patrick, I'll start with you. In terms of the activities that an organization starts with when they want to go ahead and take the first steps into DevSecOps, what do you see they typically do to enter this brave new world?
Yeah, so usually the first step is to kind of assess the pain, right? They kind of need to do an inventory. They need to know, what security vulnerabilities they're facing, what issues they're having. So that's usually the first step, is creating from the awareness, like what's out there, what do we need to fix? And that can go in both directions. Either they come already from a DevOps journey, so they got the pipeline under their belt, and they're now extending this to DevSecOps, and they're putting like a lot of the security tooling into their pipeline, or they're completely new, and at that time they're kind of like starting both end the collaboration between the teams and the technology journey. But it usually all starts with an inventory, like how big is the pain in our current company. So that means checking vulnerabilities in open source, in their licenses, in their current processes. And that's, usually where they start their journey.
So it's very much like a visibility starting point, right? Not necessarily let's try and fix all these things, but let's try and almost like take stock of what we have. Yes,
and if they don't feel the pain, they're probably not going to start it. So you might like tell them do DevSecOps, but if the pain is not big enough or they're not aware of this, they might not start it. But usually when they start, they have an idea of something happened in production or anything like during that. Pain is usually a good like starter. And then the first thing is, like in any incident, you assess what's out there. You try to assess the situation before you can actually fix that.
Yeah, I guess I'm just following on from Patrick there. One of the things that I've noticed as well is just checking that teams have a common understanding of what DevSecOps actually means, and then agreeing what your milestones are and making sure you're all on the same page. I think a lot of people see DevSecOps as a destination rather than a journey, and so they will come into their mindset of we've not done anything until we've got full automation everywhere, from patch management through to change management, rather than maybe agreeing, hey, here are some key milestones we want to hit, and then measuring our maturity throughout that process.
Yeah, and I think like joining those pain points will take you onto that journey, right? Your direction on that journey will be based off that pain, as opposed to someone hearing DevSecOps maybe at a conference or something and say, oh, we need that in our org for no reason, but we need that. Is that similar to what you've seen, Alyssa?
Yeah, I mean, what's interesting is you look at how organizations get started into DevSecOps. A lot of times it gets driven by the security team because they're like, hey, you guys are doing this DevOps thing and we need to be involved. And we're kind of sitting out here on the outside because we're not the best at like knowing how to be involved in that pipeline. And so then it goes to it like flips to the complete opposite, where we had all of these like really time consuming practices and things we wanted to do in traditional security. Now we want to bring security to DevSecOps. And it's like, we become like hyper focused on tools and tools. It's all about automation. We're going to automate the world. We're going to automate everything in security. And so the danger is that people tend to get frustrated when they realize they can't automate things. And then it's like, well, how do we do this? And so that's where I think, you see that early on in organizations as they're starting down that journey, they start thinking they're going to automate everything. And then as they mature more and more, they start to realize, yeah, maybe we need to think about people and process and how those things fit into play here and how we actually make this a part of the culture rather than just, oh, we're going to just take all the security things and, tie them into a pipeline.
And do you agree with the activities that that Patrick mentioned, Alyssa, with more of the trying to identify what the pain points are, then turning that into almost like a visibility kind of play in terms of understanding and itemizing, everything that you're touching and using?
I think the best ones do, yeah. I mean, most of the time, and you would hope that that's even just part of selling such an initiative, is that, hey, we need to look at where we are today and justify it. I think sometimes, Patrick mentioned that post-incident world where you've had some type of security incident and now it's like, oh, we weren't doing the security things, we got to do them. There is a little bit of a rush to just like start slamming in SCA tools and SaaS tools and DAS tools and let's get all the different security scanners and let's buy up all the things and plug it in. But I think the less it's driven by incident and the more it's driven by proactive desire to improve security, the better you see people kind of take stock first of where are we at now, how do we roadmap where we want to go, and then let's then figure out how we build those security practices into the pipeline.
And so this is an interesting part. So on that roadmap, then go on that journey. Once we plan that out, how do we know that the activities that are going to take us on that journey and progress us through that journey, how do we know they're actually going to be beneficial to us? And what do we need to measure in order to be able to show, hey, you know what, since doing this, we've improved by this much? How do we do that? And surprise, surprise, my first measurement question is going to you, Alyssa, in terms of you're the measuring queen in DevSecOps.
Wow, please don't think that. Oh God, no. But seriously, I mean, that's kind of the holy grail, right? And early on in organizations, a lot of times they're focused on very tactical things or the things that are easy to measure. If I've got tools running identifying vulnerabilities, well, I can look at the number of vulnerabilities and I can say, hey, my vulnerabilities went up or my vulnerabilities went down. And I mean, to a point that's valid, right? Because total number of vulnerabilities, if they're in prod, that tells you what your risk posture is. But the reality is we don't want to be catching vulnerabilities in prod, and we're hopefully catching them sooner. And so the number of vulnerabilities becomes less of a critical measure than really, okay, what are we fixing? What's hitting prod? Can we look at things and start to really understand relationships between metrics? So as we start to see organizations get, again, more mature in this, or they start to move down that line, they move away from just measuring raw numbers of vulnerabilities. And now it's like, well, let's look at, vulnerabilities per release, or, where in the pipeline those vulnerabilities are being discovered, or how many critical vulnerabilities that caused us to break a build did we discover here or there, and how do we reduce that number? You can start to tie this back to even the backlog. Then where are we? How many backlog items are getting created out of our security initiatives, and how does all of that start to relate? Because if you see your vulnerabilities go up and you see a 20% increase in vulnerabilities, well, that may indicate a problem, but that could also be because, if we look at our pipeline, our deploys went up by 30%. In which case, now a 20% increase in vulnerabilities is actually kind of better. So you have to, as you get in this, you really need to start to understand the broader the picture of what's occurring within the environment. You can't just focus on security measurements and metrics in a vacuum. They have to tie into what are we doing in measuring our overall pipeline, our deploys, the time to deploy, number of works in progress, all the things that we're used to doing in that DevOps space.
Yeah, it's a tough one, isn't it? Because you're trying to almost like measure the side effects almost that happen in the background when you make these changes. It's a tough one to almost like associate as well. Has this change actually produced those side effects, or would those side effects have happened because of the natural flow of my development, or this feature wasn't going to cause that many vulnerabilities, etc.? It's a tricky one to associate. How about? Sorry, go ahead, Patrick. I think you were going to add something.
No, I think there's a tendency to kind of simplify the measurement in a way that indeed we look at one or two metrics and then we focus on those. But there's a funny thing with metrics. If you focus too much on specifics, you can get them better, but they might not have the effect you wanted. So you really have to keep your eye on the ball. And it's not only about reducing the number of vulnerabilities, because if I hold all coding and I hold all deploys, I'm happy too, and I can get that metric perfect. But if there's nuances that we need to look at, and that's why the metrics should be used for interpretation and not per se as the final goal. That give us input and information to make our own decisions, but just making your decision on one metric is just a problem for a lot if you start doing that.
Yeah, how do you...
Sorry.
No, go ahead, Jess.
I was just going to say your risk otherwise is you can drive the wrong behaviors, right? If you champion the wrong metrics, the wrong behaviors take flight. And I think one of the things that I've seen is kind of following on from something Alyssa said is you want to focus more on where you're finding things. So your time to detect becomes really powerful rather than the number of vulnerabilities. That being said, you don't want teams to not report things because they don't want that to impact their metrics. But at the same time, for us as security teams, it might be a metric that we track internally. For me, if I see that we've got no vulnerabilities, that doesn't mean we're doing an amazing job. It probably means that something's not reporting correctly. And equally, if I see lots of vulnerabilities in some areas, I think Alyssa touched on this, and not others, it probably means that I need to look at, is someone missing a stage in our pipeline that they shouldn't be? And is there a problem with code coverage or project coverage? So I think I've certainly learned over my career so far that there's some metrics that I keep just for the security function to help us measure our impact and our coverage versus a metric that I might report further out, things like time to detect, time to fix versus number of vulnerabilities.
Interesting. I like that approach, because then people aren't gaming that in terms of, we know this is what we need to do to get that number down, and that's what we're being tracked against. So interesting. I like that. But Patrick, one thing I'd love to ask you actually is less around just the pure numbers point of view, from numbers of vulnerabilities, those kind of things, but more around the team or organization level. How can you assess whether whether it's levels of I guess just how good a team is running in terms of DevSecOps with a team, a department, an organization? How do you measure that?
Yeah, again, you probably look at many different metrics, and it's already been mentioned. We could scan your code as an individual group and say, we did really well on vulnerabilities, what we found. So we see some improvement, like you're not doing cross-site scripting anymore. So you're kind of improving on, usually that is the security knowledge. So the team is progressing on the errors and the mistakes or the issues they're getting. And then there's the other one is, imagine it occurs, how do they react to something? Will they just put it on the backlog? They don't kind of focus on it. They don't ask questions. So that's kind of how, they really kind of care about this. And then the third one I would measure on is how well they actually engage with the security team itself. So, they might be able to fix some stuff in the pipeline themselves, reduce the number, then they kind of react to issues in production and when things happen. That's a good like posture they have. But then the third one is actually like, how well do they interact with the security focus? Do they report issues? Do they ask questions? Do they kind of like talk to them when decisions are being made? So that's kind of the tree where I would look on for them to be engaged as a team, and how well they're doing DevSecOps as a team.
Mm-hmm. And much more contextual than just a set of numbers that are only as accurate as the thought that went into them, which is kind of dangerous as well. Just being providing a number, right? But,
there's this saying. Imagine you're at a party and you would measure the number of interactions you have during a party, right? It doesn't tell you how good the party was. So you can't really assess this by the number of touch points or the number of things you fixed, because you kind of need to have another kind of more higher abstraction and see how well this fits into your company. But obviously, if you don't have the first thing, if you're not talking to the people, right, there's a step to be taken. And I want to say this caveat, like we often, as we're deep in the field and we often already think about the exceptions. Yes, but what if they don't do this? So there's nothing wrong in getting the metrics up, as we've said before, but it's like the more you mature, the more you understand the nuances of this. And the same thing is happening in, when a team adopts Scrum, right? They're all about story points in the beginning. And after a while you say like, story points, well, that was just to get our bootstrapped in our thinking, how we kind of deal with these situations. And afterwards, the story points get like, way less important in the discussion. So, you need to have this bootstrap mentality, and then you can kind of progress on the more mature path. But the due point on a team is don't assess them only on the technical point. Also look how they are in the process, and then how they are on the collaboration side as well. So.
How hard is that to scale? Because obviously everyone's going to have different opinions on those kind of things.
Well, it's interesting. If you would treat all the teams the same, it's probably gonna result in some average measurement. But most of the points were is almost like a satisfaction score for people depending on the team or receiving information from the team. And that is, I would weigh that in way more than I would like look at the technical kind of numbers, but one gives the other interpretation as such.
By the way, I can't believe I've been measuring parties wrong all this time. It's a harsh way to find out. Alyssa?
Yeah, so I was going to kind of build on what Patrick was saying. That culture thing is so crucial, right? I mean, it's DevOps, it's DevSecOps. It's all about culture. And so bringing people together and breaking down silos, so to speak, or whatever, although I'm not really a fan of that particular term. But I think part of doing that is having kind of that visibility for the teams of what does that look like. So when we think bootstrapping early on and, just trying to get our feet wet in this and understanding, okay, here's kind of what we're targeting in that first kind of phase, if you will, or whatever, whether you want to call it a maturity level or, certification criteria or whatever. And then what does it look like to get to that next level? So this is how we operate today. Here's the things we need to change about what we're doing to get to that next level. And then from there, what do we do to get to that next level? And having kind of those targets essentially that the teams can work toward. And that way, not only do you have something to measure against, but you've really put that out there for the teams that they can start to see, maybe there's something as they're working in their everyday, they say, wow, this is something we could add. It's actually in our silver criteria that, to get to this silver level, we got to be doing this. So I'm going to pull that in and we're going to start doing that now. And so giving the teams that kind of just what does good look like helps build that collaboration, that culture, because now they see that, this thing that maybe felt frivolous was actually something that we value as an organization. It's going to be beneficial to our maturity in DevSecOps.
Yeah. I wanted to say that is one of the hard parts when you start, because there's a million things you could do, like what first? And that is almost like paralyzing. And my advice is that if it's so hard to choose what first, just pick one, right? And start doing that, and kind of see if you can make a dent or an improvement for that, and then reevaluate your kind of what is important. And that's going to be way better than making big plans up front to see, you know, we're going to measure this over a long period. And I also want to touch on something else. Like, yes, the tooling is kind of, you know, sometimes say it's all about the culture, but you kind of need the tooling and the culture, because the culture, the tooling often helps you, like inventory. You don't want to do this by hand, or it creates this safety from a pipeline. When you're doing the changes, you don't have to check this all the time. So both kind of go hand in hand. Usually they level up on the technology, they level up on the process, and it's kind of this gradual kind of level up. But, you know, don't make a mistake in say like, well, we don't need the tools, but also don't make the mistake we only need the tools. So it's kind of like somewhere in between there. So
Patrick's touching on a pet peeve of mine, which is when people measure their maturity just in capability or just in tools, rather than doing everything together and thinking about what are your capabilities, but what does your tool set look like, and what does your culture look like as well.
Mm-hmm. Yeah, you need that one big picture. Tash, how do you find when presenting that, like, how do you find people want to hear that information? Obviously, presenting up to different groups that kind of want to obviously keep it simple, want to understand where their risk is. Do you find that you've had different mileage in terms of what individuals want as data versus what you want to provide them to give them that well-rounded view of security?
Yeah, absolutely. I think we all enter meetings like that with an idea of the story we want to tell, and then as the audience, the story you want to hear. Mm-hmm. And certainly, as you think about your execs or even just your C team, right? There's a story they want to hear, and it's not always in line. When I've thought about how I've measured and talked about our maturity in the past with different organizations, I've always thought about, what do I want to get out of this meeting? And, what do I want to leave with? What's the thing that I want to take away? And so sometimes I have talked about my maturity to set expectations of, hey, we're a brand new function. We're not going to be here in a week's time or a year's time, and actually kind of setting that story up for how we're going to flow through something. Other times I've used it to talk about budget and how, certain amounts of budget will ultimately release certain maturity levels, right? It's to a degree, there's a pay to play model there from a maturity perspective. And then most importantly, I've talked about my prioritization. So why I'm focusing on certain areas, and especially for our execs, I've been able to play back here are our top risk levels, and actually here are how they relate to my maturity in those. And so this is how I'm going to drive down risk in those areas. So this is where I am today. This is my desired state. And this is ultimately the impact on risk. And sometimes that also comes with, please, can I have some more money? Yeah. Not always, but sometimes. Sometimes it's actually more about resource and about people championing your cause. That culture piece certainly plays a lot into it. But I think there's no, from what I've learned anyway, and I'm sure people might have different answers for this, there isn't a one win for how you want to present your maturity model. I think you really have to go in with, what story do I want to tell, but still be really cognizant of what do they need to hear from me to make whatever decision they need to make next as well. Mm-hmm.
And presumably, I mean, in terms of what risks there are of sharing that maturity state of either teams or the whole organization, presumably there are benefits, like you're able to back up the fact that you need maybe more budget, or you need, this is the state, this is where we need to focus on. It's like actual data that backs that up. Are there any risks that that can also come with that when you provide that maturity data, that maturity information?
For me, for sure. Like one might be, hey, I've not progressed in the way that I thought I would. I've not hit my objectives in certain areas. Again, for me, that comes down to actually throughout this year, we've learned we've had to pivot. Maybe our threat landscape has changed, or our customer base has changed, or our priorities as a company has changed. And so my focus on leveling up from a maturity perspective is actually being in these areas rather than these. I have used it previously to say, hey, this is where we were and this is where we are now. And hey, look at my growth. How wonderful is that? But absolutely the downside is this is where I am and this is where I want to be. And actually, maybe I haven't grown as much as I should have in some areas. But I think it becomes a trust-based exercise too, right? What's your level of trust and comfort with your stakeholders? And you have to have that to be able to give an effective story, right? That helps them to contextualize the decisions they want to make.
Yeah, helps them kind of like understand the work that is, happening in the org and things like that. Patrick, I'd love to switch to kind of like from a maturity model point of view or tracking maturity. How do companies that are obviously a little bit more advanced and able to be able to say, look, this is the plan we already know we want to go through. How do companies keep track of that going forward?
Yeah, I've seen many companies adapt one or more of the public models. Usually it's a maturity level 1 to 5, and they pick an area and they kind of say, well, we're doing the practices from this area, and they're typically in a level 1 or level 2. That gives you the visibility to where you think you are, but it doesn't address what should be the next thing to work on. So that is usually, much as we discussed earlier, the metrics give you a view to discuss, to create that shared view. The same thing is happening with the maturity model, is they kind of have this overview of all the areas they should be improving. Then usually they kind of reach a common decision on where to go next, or which area to improve after considerations by the local team, by the company kind of goals, and kind of try to align both of them to kind of see if they're heading to the right direction. And sometimes it's also fine to say, well, you don't need to continue in that area because it's good enough for us. So that is also like a balance to do that. But creating that overview is usually done by adopting an existing framework, making a few kind of prioritizations that fit your current organization, and then to have that like regular discussion, like a review once a month, kind of on the plans or when things are going. I think the good ones are not just using this as an overview that says like, oh, when you only are 1, you should go to 2, but they are having that discussion, what to do first and what not to do first, together with the team, because then you understand what the local issues are. And then they try to help and suggest that team rather than force the team to have to take something on. I'm not saying there's sometimes is a need to force things when things are at risk, but the good ones then take this model, they show it, they discuss it, and then they work on the motivation of the teams to do it, less than imperatively saying, this is what you should do next. So it's kind of, how they deal with the situations. And then slowly, by providing the information on why you think it's a good idea, they should improve a certain area due to numerous reasons, you kind of like hope you transfer that to the team taking action on this.
That kind of sounds like it's easier said than done. Like when you have like so many teams that need that involvement, whether it's execs trying to pressure on something, whether it's the security team saying, so Simon, we totally need this.
You have kids, right?
I do, yes.
Try to tell them what to do versus try to motivate them to do something.
Well,
right?
but this is it. Okay. Now that's interesting. So it's one thing motivating them to do it. If I was to ask my kids, what do you want to do? I know what they'd want to do, and I know it's not good for them necessarily, right? So it's not necessarily always just ask the development team and see what they want to do, right? It's that coaching or that discussion, input from the business, input from the security team, input from the development team. How is it common to straight away come out with one plan that everyone's happy with, or is it very much just a case of you do that bit because that's what you want to do, then the next bit is what we want to do, which is this? How does that pull together?
Oh, you want me to answer?
Yeah, no, please.
Sure. Well, yeah, it is give and take, right? But that is if a team would start working on something, you gotta give them somehow a reason, and that kind of perspective can go in many directions. The motivation could be appealing to their professionalism. Sometimes that works, and they need to see it as part of their job. For others, it is, can we close this ticket as fast as possible? But there are all motivations that help people to do some security work. But maybe they need some building block for another team to build on. So that is not different than selling anything, right? You need to give something in return before you start asking them to do something. And that, how that works, that's probably going to be team dependent, like what makes them tick and how they fit in the organization to make them, do their job there. So,
okay. We've gone quite deep now into what an advanced company kind of does, and we started out talking about what a company does who's new to DevSecOps. Alyssa, in terms of how what the differences are between trying to address the how we measure question with these advanced groups versus a group that's just coming in, is there one model that we use, or is it vastly different?
It definitely varies from organization to organization. So in that way, and I think what you see is in young organizations, it's kind of standard fare, right? Again, they all kind of like, we're going to measure, number of vulnerabilities. We're going to measure these very simple tactical things because they're just the easy numbers to collect. Where you start to really see it diverge is as those organizations mature, because now they start to see, okay, what is of value to us? If I'm going to go before my, executive committee, or I'm going to go to the board and I'm going to present on security, one of the dangers in doing that ever, when you put together that presentation, is going in there and saying, here's all the bad things that are going on, right? Because, speaking to the motivation that Patrick was talking about, nothing is more demotivating and nothing is more sure to tune your executives out of what it is you're trying to get them to do than to give them all the doom and gloom without, any kind of, horizon or, hey, here's what we're seeing that we can build upon, and that's how you kind of build that motivation. So as organizations mature, they start to look for, instead of just, okay, let's measure risk, let's look at what security is doing in terms of our overall product goals, right? And this is where I sit down with executives, and it's, hey, you need to be building a value model here for security. How is security making your pipeline faster? So we've heard these terms like, paving the road and things like that. Well, how has the secure path become the one that is the easiest path for our devs to follow? And as a result, security is driving, more deploys per day or whatever. And I know I say that, and the developers out there are immediately like, what are you talking about? Security never makes us faster. Security always slows us down. It doesn't have to be that way. And I've definitely worked with different organizations where I've seen how, bringing, say, threat modeling into the user story level and having that information available through the pipeline actually speeds up the pipeline. And so that becomes the other piece then. Again, I kind of alluded to this before. It becomes less about measuring security in that just here's security. It becomes, how is security fitting into the pipeline? How is security actually enabling, say, again, more deploys per day or whatever's meaningful to you from the product perspective, from the business perspective, measuring security in context of those elements. That's the sign of an organization that's really maturing in this journey.
Yeah. Cool. And can you believe we're already 35 minutes in? So I want to ask one final question, which is to end with, in and around maturity, which is an important one, because we've talked about, how we can track maturity, how we can, assess maturity, I guess, with some of the larger organizations and things like that. But when we think about how we actually carry out that assessment, Tash, for example, a self-assessment, maybe from developers, or a assessment that we would want the security team to do for all groups. How do we actually go about rolling out that kind of assessment to an organization?
Well, hey, self-reflection is always a great thing. So we're always going to start with this, that a period of self-reflection to really feel like you can be honest with yourself around where you stand is great, but it is subjective, right? We're always going to see the best in ourselves, or we're going to see one point of a story. I think context is king here. It depends what you're measuring your maturity for. Is it to really understand for personal growth of your security program and your engineering function? Or is this for a thing? Is it for an auditor? Is it for your board? Is it for measurement? I think that helps. And so I would always suggest starting with that self-assessment, having those conversations with the engineering team, but let it be security team led, so you can bring a little bit of objectivity. And then depending on what story you want to tell, or how this is being used, use a third party. I think having someone who sits, whether that's outside your company altogether, or even someone from a product perspective. I think it's really important that Alyssa mentioned product. That's what we're all here for, right? That's why we have jobs. It's to build a product, to release features to our customer base. And so having someone who can be product focused, who can help navigate the conversation to get back to your goal, that maturity goal, start to carry out those interviews with you. How are you on patch management, on change management, those types of things, can bring a level of objectivity to it. But I wouldn't rule out having a third party. There's plenty of companies out there that will use many established frameworks to measure you. But I'd always start on that self-assessment, even if it's just for that period of reflection, to really be honest with yourself. Often I found, Patrick spoke about motivation rather than asking people what do they want to do. I found personally that asking people to really reflect on where they think they are in that 1 to 5 model, and making sure they're clear, I'm not expecting them or wanting them to be at a 5, can drive a level of motivation that you wouldn't get if you went straight to third-party assessment.
Yeah, I think also that transparency is really key about why you're doing it, so that if you don't want it to necessarily turn into something defensive from the development teams. You want it to kind of like be very much, we want to do this to improve, so we can understand how we can develop faster, or how we can, so that it's of value to them, and then they can kind of be more honest. I love that approach. Do you think, Tash, that what works, you mentioned third-party assessors almost. Do you feel that there's almost like this cookie-cutter approach, that what works in one organization can, you can just move to another team, move to another company and say, hey, I'm going to use this exact same maturity assessment and it should just work? Or do you feel like there's some customization that needs to happen for your orgs?
I've definitely seen the cookie-cutter approach. I think a lot of auditing companies certainly do that without the context of what your threat landscape is, what your risk level is, what data you hold, or what value you look after from a security perspective. But there are companies out there who will contextualize, who will look at your risk landscape and make sure your controls are appropriate. I think it's important to recognize that a good sign of maturity is a company that looks at appropriate controls for their threat landscape, not necessarily the full-fledged of everything they can do. Irresponsible spending for me is a lack of maturity, right? Just throwing money at a problem or focusing on tools is a lack of maturity. And so a good third party will look at that contextualization of what you're trying to protect, what's your risk landscape, not necessarily what your budget is, because sometimes that unfortunately doesn't line up, and using that to really build that maturity model for both where you are right now, where you should be, and then also helping you to understand where the industry is. Now, I think the industry tends to be a little bit below where we should be trending, but it's important that, if you are a small business focused on a SaaS service, that you're not comparing yourself to financial services, but that equally you're holding a high bar for you and your company and your customers.
Awesome. Well, we're eating into the break a tiny little bit, but I do want to just eat a tiny bit more into that break time at DevSecCon. I just want to ask one very, very quick question of each of you. The same question. What is your one golden tip on measuring DevSecOps maturity? And I'll ask Tash first, then Alyssa, and I'll be horrible to Patrick, who goes third and might need to reuse an answer. But Tash, what is your one golden tip for measuring DevSecOps security?
I will go back to something I said earlier, which is what story do you want to tell, and what behaviors do you want to encourage? Your metrics should underpin those behaviors that you want to encourage.
Great advice. Love it. And Alyssa?
Don't let security off the hook. remember that the idea of shared responsibility doesn't just mean everybody's responsible for security. It means security is responsible for making sure that software gets out quickly and with stability. Your SREs are responsible for security and making sure that things deploy quickly. Remember, that's what shared responsibility is actually all about.
Awesome. And finally, Patrick.
Yeah, so I would say, think about when security department doesn't exist anymore, would people still be doing the right thing?
Oh my goodness. When does the security team go away, Patrick? Well, no more comments. Let's just end on that bombshell. So thank you very much to Tash, Alyssa, and Patrick. Sorry to leave you on such terrible news there, but we wish what a wonderful discussion that was. Thank you all for a great discussion, and have a wonderful rest of DevSecCon24.
Hey, we're back again. How are you all doing? How are you doing, Matt?
I'm doing well, Brian. Thank you.
I was just following the latest or the last panel discussion, and I love that they started with stuff on culture. And I think culture is something that is very important within security and development in general. What do you think?
Yeah, I mean, it was a topic that also kind of rose to the fore in the panel that we did for the North Americas yesterday. You know, you can kind of have all the tooling and process in the world, but you know, to really effect change, I think you know, it's all about the people ultimately. And as we all know, in technology, the hardest problems in technology are always about people.
Absolutely, but I also love that, like, in the end, Tash mentioned something like, if you're just a small company, don't compare yourself to a big financial service. And I think that is also a key valuable, a key thing to do, that within your own measurement of how big you are, you should be doing a good job considering how big you are or what you're doing, instead of comparing yourself to the larger enterprises.
Yeah, I think that's true.
All right, welcome back. And it's, for me, it's lunchtime. It's almost lunchtime for you, I guess. Well, I assume that you're all based in EMEA, but you can be in other regions. If you're there and if you're still with us, thank you very much for being here. I really appreciated that you're there. Feel free to jump on the Slack channel and have further discussions. Ask the speakers about anything you basically want, about their talks, about their favorite color, their favorite stuffed animal, or whatever you like, but do it on the Slack channel. Everything is happening over there. In the meantime, I want to just put some attention on the community stuff, because next to that, we have DevSecCon and we have the DevSecCon community online. There are also local chapters. We currently have 3 local chapters, if I'm not mistaken. Correct me if I'm wrong, Matt, but I think we have London. We have a general one in Germany, which is, during COVID, it's also a bit like, it might split up into the different regions in Germany because it's quite big. And we have one in India. But if you think like, hey, running a local DevSecCon chapter is something I want to do, go on the Slack, reach out to us, reach out to Sam in that case. She is running all the stuff. You have seen Sam like yesterday on screen, and she's always there in the Slack community. And we can set you up, we can help you out, and it would be great to spread the knowledge all over the place. Anything from your side, Matt?
What have we got coming up this afternoon, Brian? I know I said earlier I'm really looking forward to the runtime security with eBPF. What were you looking forward to this afternoon?
I am really not sure. I think it's hard to choose. I love the one that you're calling out, but I'm just hanging on to the stream anyway, and just see what's going on there, because what I believe is, for many conferences, it holds that if I pick topics, that's because I already have some knowledge around that. And if I just stay on board, and I might learn a thing or two on things that are not so directly connected to me, but can be important. So I'm just hanging on to the stream. And because it's just a one-track thing, it's quite easy. I did try, like, I asked you, like, on the kids track earlier during the opening. I tried to move on there, but they kicked me out. I need to shave, I guess, or something like that. I'm looking way too old for a youngster and nowadays. So
well, I hope folks managed to get an hour or so this morning to watch a few sessions and found that kids track useful. You can obviously catch up with all the sessions from both the North America event and APJ on YouTube. I know the team is working tirelessly behind the scenes to get those uploaded. I think there's a whole bunch of stuff that's already there, and the remaining ones are being uploaded as we speak.
yeah, and absolutely. Think about, even if you're doing other things, the kid track is just an amazing thing to put your kid in front of and have some actual quiet time. So just nobody knows what you're doing anyway. You're working at home watching Netflix, or preferably watching one of the sessions. But hey, you can pretend. I'm cool with that. Anyway, I know that in the end we have something like the DevSecOps Leaderships Awards. I think we're closing with that. So I haven't looked into who's nominated, to be honest, but I'm always astonished by how many people are passionate about this and how they are doing and what they're doing for their community. So again, I'm reaching out to that. Like, if you want to set a community, we can help you out. But we're ending, like, at the end of this whole block, we're ending with some DevSecOps Leaderships Awards and some announcements on new stuff as well.
And of course, we should give a shout out for those who are thirsty for more developer security related content. We have SneakCon coming up. The call for papers for SneakCon is now open. Have you submitted anything, Brian?
I am working on a new abstract, so I just wanted to be perfect before I submit it. And yes, I will submit something. I'm working on something on serialization and serialization problems, and I hope the committee finds it good enough. Because even though I work for Sneak, I have to go through that committee. I'm not part of that committee this time, so I cannot favor myself. I always try to do that, but it never worked for some reason. They're onto me, I guess. One thing, know that we have sponsors. Go to the sponsor booths and check them out. Some of them have nice prices, so you can maybe win a thing or two that is nice for you or your kid, like a Nintendo Switch. Is also a great thing to hand over to one of your kids if you want some quiet time. And we have the DevSecOps for Good thing. When you registered for this conference, you probably already send in what your favorite charity is, where we donate the money to. So keep an eye on that as well.
I think we're out of time here, Brian. I'm getting red flags from the backstage team saying we need to get off now.
Okay, we get off. See you later. See you in the next break or later on. Bye-bye.
Hi, my name is Max.
Hi, everyone. I'm Natalie, and we're so excited to have you here today.
So a little bit about myself. I'm a tech lead at Babylon at data science and analytics platform. And my interests include infrastructure, data, and machine learning.
And I'm Natalie Godic. I'm a cloud engineer in the Data Platform Foundations team. I love all things infrastructure and have a particular thing for security. So overseeing our data platform really allows me to draw these passions of myself. And two words about Babylon, who we are. We are a digital-first, value-based healthcare company, and we're on a mission to bring accessible and affordable health service into the hands of every single person on Earth. Now, that's quite a challenge, right? And as you might imagine, as a healthcare company, we deal with loads of sensitive data. The data needs to stay secured and protected at all times, while also allowing us to innovate and create products that will bring us down the road of our mission. Our security policies tend to get very complicated, and we often find ourselves challenging the limits of our cloud providers and our product providers of the technologies that we use. And on that, over to Max to introduce you to your very complex security policies.
Thanks a lot, Natalie. A lot of companies have seen the benefits of using cloud for everything from storing data through running microservice infrastructures to machine learning and so much more. But once you store your data in the cloud, all the APIs that protect it are public. Natalie already explained what our mission is, and while we're fulfilling it, we cannot compromise security of our members' data. We cannot keep the public APIs public much longer. So how do you do that? Most of the things we're going to cover today are going to talk about our adventure with GCP, but these concepts are not foreign to other platforms, and you will be able to take anything that you've seen here and adapt it in your own context. Number one, let's take a look at a sample request hitting a public API. We need to make sure that we consider every single aspect of these requests. In a classic RBAC scenario, a user makes a request. We check the identity of the user, and we compare it against a list of users that should be able to access given resource. But what if your resource is in the US and data sovereignty laws prohibit any UK employees from accessing it on UK soil? We need to make sure that any policies that our legal, compliance, privacy, and security teams craft can accommodate these sort of nuances. And it isn't uncommon in the world of healthcare to have many vastly differing regulations that across borders will tell you that the data of a citizen of one country need to be processed in a certain way that is different to data of a citizen in another country. If you thought GDPR was bad, this stuff can give you proper nightmares. Some of countries will have very prohibitive laws, while others will allow you to be a little bit more adult on your own. We wanted to make sure that we don't just comply with the rules we're giving in any given country. We want to make sure we act in the spirit of the regulation. If the regulations want us to make our members' data secure, we can't do the bare minimum to make that happen. We will do everything we can. So instead of considering just the identity and the role of the user, we want to take a look at as many things as we can, including, yes, the identity, but also things like where is the request coming from, what kind of data is being requested, as this might affect when we should say yes and when we should say no to a request coming in. We also want to know things like intent, as data might be available for one purpose, but not another. And finally, for instance, auditing purposes, we want to be able to tell why was a permission granted in the first place. So let's start delving into the resources that you can create to make all of that happen. First up, using good old IAM. But already here, there is something that if you are not doing it right now, you should start as soon as possible. Because the way you can grant a person a role is made so easy. It's an absolute miracle of modern cloud APIs. But even in a simple example like this, you can already start encoding some additional information about, for instance, why was the role granted in the first place? And very importantly, when should the permission expire? Because if you give somebody a role with indefinite duration, at some point, somebody will forget that that role was granted and that the user had it. This complicates the entire security infrastructure and reasoning about it. And so again, if you're not doing this, this is one of the simplest things that you can do that will remove a massive chunk of your potential attack surface. Because of all that zombie users that have access to data that they don't even use can be used against you. Moving on. In the same spirit, let's say that a user actually needs access to some data set. So we want her to get permission. But does she need access to all of the data? Most of the time, no, she doesn't. And what's more, she shouldn't. Raw data, especially in healthcare, can be avoided to be seen. And that's a big story for a completely different time. But in this session, I'm just going to show you in a very simplified example how you can manipulate the data dynamically when the user is requesting access. And yes, you can do this by creating a new data set that is maybe anonymized and so on. But that means that you have to have all of these data sets ready. You have to predict what the user is going to want to see, what the regulations allow them to see, etc., which, to be honest, arguably is not the job for data engineering teams. All of that can introduce delays, and delays cost money. And in some cases, they reduce security as well. What you can do instead is to mask the columns or even rows dynamically so that the final data set that the users get to see includes all the data that they need to do their job, but it doesn't include anything else. And so now, if somebody tries to attack you, they won't be able to target any of your zombie users as they do not have indefinite permissions. But even if they get access to somebody potentially senior, the data that they see is going to be relevant only to the particular task that the senior person is doing right now. The third thing I'm going to mention is Google's VPC access controls. This can be trickier to implement without that particular API, but you can do it using other tools like VPCs or firewall rules. Service perimeters give you direct control over who can access which APIs and in which context. And that's massive because as I've mentioned before, giving one user access to a particular data set is not enough, as when UK employees working from US office, even though they retain their original identity, I mean, nobody really changes their login credentials while crossing the border. In that case, they should lose access, as it might be a massive violation to access UK members' data on US soil. Access controls give you the power to make these nuances enforceable. We can now very easily say not only that a user has access to some data, but also where from. This is the customary visual aid for all the folks that are more visual in the audience. And so now you can take all of these small things, which can and often are managed in different ways in different places, and you can really just make them one quick and simple process. A user submits a request to access data, which can be done very easily through Git. Then in a CI/CD tool, we can get the full context of that request and validate it. Potentially, we might have to intercept the request and edit it in some ways, like for instance, removing a user if they don't satisfy our policies, or changing which IPs the data will be accessible from depending on what the data includes. And then we orchestrate all the cloud resources using Terraform and TerraGrant. End-to-end in potentially 5 minutes. So when your users are asking for access to data, you can very quickly tell them what they can and cannot access, and then give them their own private Google project or Kubernetes namespace. This is how a sample policy might look like. It can really be just a simple YAML file that lets you specify which attributes of data and users can go together and which don't. Some of these fields will depend on your organization, and you should really make it as custom fit to your needs as possible. This is a very simplified version of something most companies might want to codify. In this particular case, we're looking at a dummy policy, which allows access to raw cities and diseases in UK, as long as the patients they refer to have given an explicit AI learning consent by any UK-based full-time employees with enhanced DBS check if they wanted to use it for AI model improvement. The access is also going to happen through a virtual desktop infrastructure because the data is raw, and there is going to be no internet access. Now, any teams that need to make these decisions can get involved, directly impacting how the data can be accessed across the organization, but without ever having to talk to engineers or getting familiar with the data. And from our user's perspective, this is how a sample request might look like. I want person 1, 2, and 3 to be able to access this particular table but only the rows that were consented for and with dynamically masked columns in this particular way. In addition, my project is going to expire on the 1st of July 2021. The data is going to be used for AI model improvement, and a reason for approval and maybe description of the project is included in Jira ticket Jira 123. And all of that is a direct input to a Terraform module that can then take all of the resources I showed you before and many more and provision them together so that all of the complexities are hidden from people that do not need to see them. As I mentioned before, in the CI/CD tool, we're going to then enrich the request with all the metadata we need to make the decision based on policies, and then we can directly compare the two. And that's me. So now let's see what Natalie has prepared for us.
Thanks, Max. Right, so now you have seen how to analyze your requirements in terms of security and how to construct a policy that will be flexible and will encompass all of the needs that you have in your organization. Now it's time to shift the focus onto what happens after. You see, when you use a cloud platform, all of the requests that happen and all of the events that happen within it are API requests, and each API request produces a log. Logs contain masses of very important data that you definitely should store centrally and use to produce insights, analytics, alarms, and have a really good visibility onto your platform. Now, I will continue using the example of GCP, but you can apply the same principles whichever platform you use. In GCP, each resource in each project will produce a log, and you can use something called logging sinks to route those logs into a specific location. These logging sinks are just log pipelines, and if you use Logstash or CloudTrail or anything else, you will likely have a similar pipeline. Now, I would suggest that you would want to have your logs in a central location, such as a centralized logging project, in order to enable the analytics later down the line. And this is quite easy to set up until you start having VPC service controls and service perimeters. You see, when you have your data that is sensitive, you will want to protect it with service perimeters like Max described. But also logs are sensitive data as well and specific to your organization. So you will want to have a service perimeter around the logging project too. And then you start having an architecture that is quite complex with some projects within different service perimeters, others outside, because not all services have to be restricted. And then the logging project inside perimeters too. And how do you enable communication, since the perimeters serve for this particular purpose of not allowing any data to go outside of it? Well, you can use egress rules to allow specific data to go into a specific place. In this case, let's say that we want the logging sync to route the logs from our project A into the logging project. And the egress rule will say that the logging API is allowed to exit the perimeter if the data is going into the logging project. And then on the side of the logging service perimeter, you will want to say that the identity of the logging sync is allowed to enter data inside the service perimeter. Whatever logging pipeline you use, you will have an identity of this pipeline, and this identity can be used to set up IAM roles, permissions, and also network traffic rules if your platform allows for that. And this is exactly what we're going to do with GCP. We're going to allow the traffic with the logs from the originating perimeters to exit if they are going into the logging project, and also allow the logging syncs to write into the logging service perimeter. In order to make this setup automated and a little bit more simplified, you will want to consider having top-level folders in your organization. In general, the more high-level your setup can be, the better, because then you can just set up the logging configuration on the top level and forget about it, and everything else inside your platform will be already covered. But maybe you have a requirement to store logs separately, depending on the environment, maybe non-production, production, maybe location, or maybe department needs to be stored separately. In that case, you can say, okay, let's have top-level project folders that signify those separated spaces, environments. In this case, I will use an environment as an example, production and non-production. Then we create a folder logging sync, and we'll say that all children are included in the logging sync. And we create separate spaces for storing those logs to comply with the different data locality or storage requirements. Each of the logging syncs, again, will have a service account, its writer identity that will be used to set up access. If we look at this architecture in a little bit more detail, it will look something like this. You have your GCP organization, and you enable audit logging on all services. This is what is going to give you the most data. Then you say that you have top-level folders, for example, production, and all of the projects that go underneath will have to live within folders or underneath just the top-level folder. Then on the right-hand side, you create the audit log prod project, which will, for example, contain a BigQuery dataset. And we create a folder logging sync from the production folder to this BigQuery dataset to store logs in BigQuery. Why BigQuery? Well, because it's a data store that is extremely scalable and enables you to do analytics that we will take a look just in a second. Whatever service parameters you will have around your source projects will have to have an egress policy. That egress policy will allow logs and BigQuery API to go outside of the perimeter into the logging project. And on the side of the logging service perimeter, you will have an access level, and you will add an access level condition for each of the logging sync identities. And also an IAM role for the identity to write into the dataset. And everything will be encrypted end-to-end thanks to GCP, encrypting everything, all data in transit, and us using a service identity, a service account identity. When you use Terraform, you can actually simplify the setup and make it nice and automated. You will have a module. Terraform allows you to create a module which groups resources that have to be deployed together. In this case, we have seen that we create a folder logging sync, a BigQuery dataset, an access level condition, and some IAM permissions for the identity of the logging sync to write into the target dataset. That will be our GCP folder module. And then you code it in a way that in the input variables, or TerraGrant if you use TerraGrant, you will just have a list of folders that you want to create. And you might want to have a flag that says that a folder is audited, or maybe logs enabled, something like that, something descriptive of saying that this folder is the top level folder where the logging syncs will be configured. And then, of course, the module will create your folder and create all of the logging configuration for you. And then you don't have to worry about anything else. All of the projects that will be created underneath will be covered with the logging syncs automatically. And when you need a new folder, you just add one line in the input. Very simple, very nice, like that. Now, I've mentioned a couple of times the BigQuery, analytics, querying. What do I mean? What if you want to see who accessed your data in production? How do you do this now? Is it easy to do? Do you have to go and search somewhere through the log trails, or maybe some specialized security software? Well, if you have your logs in the central place in a store that is queryable, you can have a really simple query like this and select user emails from Cloud Audit Data Access. In this particular case, this is a Google Cloud logging table that contains all of the data access logs. And you might want to filter it by resource or email or time zone or region. Or maybe you want to see policy violation statistics across your entire platform. So you've written all of those policies and now you want to monitor them. This particular query actually comes from a really cool Medium blog post that describes how to create a dashboard about VPC policy violations in GCP. And this really just gives you all of the data that you need. Now, you can't really set up real-time alerting on this because logs come in not in real time, but every hour, I believe. But this will still allow you to create really nice visibility and really nice dashboards across your platform and understand who is trying to access what, where they're not allowed to, which regions might be affected more. Maybe there are trends in violations, and you need to kind of keep that in mind. And the third thing that I want to show is usage statistics. Now, this query starts to get a little bit more complicated, but fear not, it's actually really easy. You can take, for BigQuery, for example, you can take which user has queried how much data per day. And then you can create dashboards like this. Now, all of the numbers here are randomly generated just to illustrate the possibility to you, but you can actually classify your usage and the costs of each project, or per region, or per GCP project, see the stats and the differences between usernames. And this starts to get really, really interesting when you start comparing this data over time. So you can see how much the usage of your platform is growing, for example, or which project and which team is being the most active, or maybe which query or which analytical project is starting to cost a little bit more than expected. And this kind of data really will allow your analytics teams to be more independent and to optimize the way they work, and really have a good visibility into what they do on the platform. And so this is a BigQuery usage example, but similarly, like all of your logs contain so much data and so much insight that you should really, really think about using it and building some dashboards that are useful for your company with that. And that is all from us. If you have any questions, we're really happy to answer them, and would also like to say that we're hiring. Thank you very much.
Hi, welcome at DevSecCon. It's a pleasure to be here. I'm Philippe Rijk from Belgium. I'm actually presenting from Belgium this time, which is kind of weird, but we've gotten used to it over the past year and a half, I would say. Nonetheless, I'm still looking forward to real events, real conferences where we can actually see people following talks and stuff, well, seeing computers and walls and stuff like that. But hey, that's what this is all about, and let's do what we have to do in the circumstances that we have here. So let's talk about token security in single page applications. That's basically going to be the setup for the next 30 minutes. And I'm going to walk you through a couple of scenarios to discuss some kind of a nuanced problem where there's no real one size fits all answer. So if you were hoping to find final answers in this session, I'm going to have to be disappointing because it's not going to be like that, but I'm going to give you some options and help you think about this challenge in modern single page applications. Let's start at the beginning. Let's start talking about local storage, because if you're going to look at token storage solutions, you'll find people saying like, yeah, local storage is awesome. And you'll find other people saying like, oh my God, never put stuff in local storage. And the truth is somewhere in the middle. So local storage is this browser-based storage area. It's basically a fairly simple mechanism. It has key value storage. So you basically set an item and you get an item with a key and a value. That's as simple as things get. Storage-wise, this is really easy to use. It's not the browser developer's favorite API because of some performance issues, but nonetheless, it actually works really well for storing something simple like a token. And you may have found some advice that says like, yeah, this is cool. And you'll find people saying like, yeah, not really, this is dangerous and you should never do that. And that's what I want to talk about in a couple of minutes. Before we get to that, a small word about myself. I'm Philippe de Rijk. I used to travel the world to help companies with complex security problems. So I do developer training where I help people understand vulnerabilities and defenses, but I also do specialized consulting on topics like exactly this one, or OAuth and OpenID Connect and all of these fairly advanced and complicated technologies. So if you want to know more about that or about me, there's a website, Pragmatic Web Security. That's my company. You can find all information there. And of course, you'll find me online as well. But enough about me. We only have 30 minutes, so let's talk about token security. Let's talk about the dangers of local storage. So the thing is, and people are kind of right about that, storing data on local storage is making it easy for the attacker to grab that data if something goes wrong. So let's assume that the attacker can exploit a vulnerability in your application, allowing the attacker to, for example, execute code through a cross-site scripting vulnerability, or to compromise a advertisement that you load and all of a sudden code executes in your application. That's the red block on this slide. That code can read local storage. And if you put sensitive tokens in that local storage area, an attacker able to inject some code in your application will be able to read that code, ship it off somewhere else, and off you go. And that attack is really, really easy. As in, the code to do that is exactly these two lines of code. And I'm sure you can write that as a single line of code as well, just a little bit less readable, but you get the idea. So this is not a new attack factor. This is not something that should be shocking to you. This is something that's very well known, like, yeah, we can do that. And that's why you'll find advice that says like, yeah, you should never put stuff in local storage because an attacker can steal it from there. And since this problem is well known, you'll find defenses built into technologies like OAuth, which try to counter these attack scenarios. For example, in OAuth world, your single page application would use tokens, an access token to access the API, and a refresh token for long-term access. As in, your access token is valid for 10 minutes, so you use it for 10 minutes, and then afterwards you use a refresh token to get a new access token, and you do that again and then again and again. And that access token is very sensitive. It gives access to the API, but the refresh token is even more sensitive because a refresh token gives the attacker the ability to get new access tokens over and over again until it expires. The thing is, in an OAuth scenario with a backend web application involved, this refresh token is kind of secured quite well because it's stored on a server and it can only be used by the application which authenticates. But that doesn't happen when you use refresh tokens in the browser. And that's kind of a new development, development in the last 2 years, basically. And such a refresh token in the browser is a bearer token, which means that anyone who gets hold of it, an attacker stealing it from local storage, will be able to use it, which will give the attacker eventually access to an API on behalf of the user. And that's something that we might want to avoid. So in the OAuth world, The specifications state that refresh tokens that are used in front-end applications like a web app, they should require additional protection. And concretely, in a browser-based environment, that protection is something called refresh token rotation. And refresh token rotation works as follows. I'm going to explain that with a timeline because that's the easiest way to visualize this process. So the application, the front-end app, uses a legitimate OAuth flow to obtain tokens, AT1, access token 1, and RT1, which is refresh token 1. And access token 1 expires after X amount of time, let's say 10 minutes. So what the application is typically going to do, it knows this. It says like, yeah, in 9 minutes, in 9 minutes, it says like, yeah, my token is about to expire. You know what? I'm going to get a new one. And because of refresh token rotation, the app uses a refresh token, RT1, and receives a new set of tokens, both access token and refresh token, AT2 and RT2. And again, AT2 expires in 10 minutes. So in 9 minutes, the app does the same thing with refresh token 2 to get token set 3, and the same 9 minutes later with token set 3 to get token set 4, and so on and so on. This concept of refresh token rotation ensures that a refresh token, RT1, RT2, RT3, and RT4 can only be used once. That's the whole point here. So the idea is that if somebody steals it and it would be used twice, then we know that something is wrong and we can actually take some defensive action to ensure that we can limit abuse. And that scenario would look like this. So the application is just doing what it does using refresh tokens. And at some point in time, the attacker injects or succeeds in executing a piece of malicious JavaScript code in the application. And the attacker is going to steal stuff from local storage, and there's a refresh token in there, and the attacker is like, ooh, interesting. I have now a refresh token which is linked to this application and this user. So what if I just use RT2 so I can get AT3 and RT3? And that's going to work because that's how bearer refresh tokens work. So the attacker at that point has a token, AT3, allowing it to access an API on behalf of the victim, which is a big problem. But, and this is the kicker of refresh token rotation, the application doesn't know that this has happened. Otherwise, they would have prevented the code from executing in the first place. So the application is kind of oblivious here. And at some point in time, it's going to go to the authorization server in this case with refresh token 2 and be like, hey, can I get new tokens, please? And at that point, the authorization server sees RT2 being used again, the second time. And it says like, oh, no, this is not good. That's the whole point here. Refresh tokens are only supposed to be used once, so we can detect theft of a token and we can take corrective action. In this case, that means we revoke all the tokens associated to RT2, which prevents the attacker from using RT3 or 4 or 5 or whatever token that the attacker has. And that's the concept of refresh token rotation. Now, there's a very big problem with this approach. From a high-level perspective, this seems to work quite well. But what this approach fails to understand is that the attacker can do a hell of a lot more than simply steal data from local storage. And that's why you find a lot of people focusing on this local storage like, oh my God, they can steal data. And they completely forget that the attacker can do all kinds of other dangerous things. It's not a single event. It's not steal data and abuse that data afterwards. The attacker can manipulate the application any way they want. I will come back to that in a second or in a couple of minutes as well. So this first takeaway is really important. It's a very common misconception that cross-site scripting or malicious JavaScript code is a single event, one point in time, while it can be a continuous, ongoing attack. That's essentially takeaway number 1. So if we have this problem with local storage, let's look at an alternative. Why not look at something else instead? And let's look at cookies here. Cookies are very old. Lots of people don't like, well, people like Christmas cookies here, but lots of people don't like cookies in the browser. And for some good reasons, but also, well, they are what they are, and we have to deal with them anyway. So what's the deal with cookies here? Well, cookies are kept in a cookie jar. So conceptually, this looks very similar because it's a storage area in the browser. The difference is it's not code, or your application code doesn't have to put cookies in the cookie jar. The browser does that by itself. But cookies can be accessed from JavaScript. So your code on the left, the blue code, can read a cookie from the jar. But if something goes wrong, the attacker can use a malicious payload, which is almost exactly like the one we covered before, to read that cookie jar as well. And again, that's a well-known problem. That's something we've known about for 20 years or something. It's like, oh yeah, that's a problem. And the fix for that in the cookie world is a flag called HTTP only. And that HTTP only flag basically tells the browser this cookie is for HTTP traffic. It should not be accessed from JavaScript. And adding that simple keyword to your cookie configuration when you set a cookie will ensure that malicious code can no longer access that cookie. Awesome, right? I mean, this is a cookie that can never be stolen through malicious JavaScript. Wonderful. And again, from a high-level perspective, you might think like, oh yeah, that's a good solution, which you'll often read about as well. Like, yeah, just use this because it's better. But if you investigate the security properties of what's really going on, the security is kind of crap. I mean, from the outside, the door probably looks closed until there's a bit of wind, and then your cheetah will crack and your door will be blown wide open. And it's the same story with cookies in the browser. Because the attack vector is not a single instance or a single occurrence of a bad thing. It's the fact that the attacker code is executing in the application. And the attacker can do whatever the hell they want. So they can't steal cookies. Good. What else can they do? They can steal data from the page. If it's a payroll application and the attacker can execute code, they can just scrape all the data and send it off to someone else or to a server controlled by the attacker. They can steal data from the application. They can modify the UI. Banking Trojans love to do this. They add a transaction in an online banking app and they hide it from the user. They just modify the UI as if the transaction was never there until you sign your transactions and boom, off goes your money. Kind of dangerous. And the attacker code can start sending requests to a backend, and the browser will attach cookies on those requests. And the backend server will have no way to distinguish between a request coming from the red code, the malicious code, or the blue code, the non-malicious code, because it all runs in the same environment. And that's the real threat of cross-site scripting, of malicious JavaScript code. The attacker can do whatever they want once the code runs in the application. So if unstealable cookies, I know unstealable is not a word, but it kind of expresses what I want to say here. So if unstealable cookies are not secure, because we have things like session writing where the attacker can send requests with cookies anyway, what does that mean for tokens that are not kept out of reach for the attacker? Well, the story isn't very good, actually. Here's one attack scenario that circumvents refresh token rotation altogether. So the app does what it did before, handles tokens. And the malicious code is injected at some point in time and steals the latest refresh token. But it doesn't use it. It just steals it and it sits on it. And the app notices that the token is about to expire, so it requests a new token. Use RT1 to get AT2 and RT2. And the malicious code sees like, ooh, you got a new refresh token. That's good. Let me steal that one as well. I'm going to steal it, but I'm not going to use it. Just going to send it off somewhere else in case we want to use it later. And then the attacker code detects that the user has closed the application. You can listen to close events, or you can have a heartbeat mechanism that sends a request every 10 seconds. And if that stops, then it's fair to assume that the application of the user has gone offline, that it has been closed. And at that point, the application is no longer running in the browser of the user. So the application is not going to use the latest refresh token, RT2. So the attacker can now be like, ooh, I'm going to use RT2. And I'm going to request token set 3, AT3, and RT3, and I'm going to get that. And there's nothing to detect here because the application has been closed and the application will never reuse RT2. So in this setup, refresh token rotation is a useless defense, just because we made the attacker a little bit smarter and made the attack a little bit more sophisticated. That brings us to takeaway number 2. Takeaway number 2 says that the attacker can do anything that you can do as a developer. So if you can think of something as a developer, the attacker can do exactly the same thing in the malicious code because the attacker has the full privileges that you have as a developer once that code executes. And that's a very, very important thing to realize. So what can you do then? Well, not much, actually. Sorry about that. Well, we'll get to a couple of solutions in the second part of the presentation here. One of the things you can do is you can make it a lot more difficult, or you can reduce the number of things that can go wrong. And one way to do that is the use of a web worker. And that's actually what some of the advanced OAuth SDKs are doing. This example is based on the Auth0 SDK, which is how you would implement OAuth flows for Auth0 in your front-end web app like Angular or React or whatever. And that SDK, once you load it, it's a piece of JavaScript. That SDK will launch a web worker. And a web worker is a fully isolated environment in the browser that can run in parallel with the main application. So it can do some calculations, it can send requests. And in this case, it's going to keep that refresh token in a secure, isolated environment. So the steps here would be the SDK is bootstrapped and it starts an OAuth flow. Don't worry about those details. And it's going to ask the worker to handle the final step of that flow, which will result in tokens. So the tokens are, the worker handles that. The tokens are returned in step 4 and are now available within that web worker, nowhere else. In that web worker, the refresh token is kept securely, and the access token, the one that is used by the application to contact APIs, that one is shared back with the main application. So the application only has an access token, no refresh token. What if we need to use a refresh token? Well, the application will ask the web worker to use its refresh token. The web worker will run a refresh token flow with the authorization server, get new tokens in step 8, keep the refresh token, and return the access token to the main application. And that's essentially how you would use a web worker in practice. A very solid isolation mechanism, fully handled within the browser. So it doesn't require too much code to use or benefit from this isolation. That's actually pretty awesome. This is a really good pattern, by the way. This is a job well done by the library developers. This is absolutely great. So sensitive tokens are only available in the worker. There's no advertisements, no third-party code, no nothing in that worker. So this is actually a pretty secure environment. And we use the web messaging API to enable interaction. So this is takeaway number 3. This is actually a really good pattern to isolate sensitive functionality from the main application context. It doesn't really solve the full problem, but it makes it a lot more difficult or even virtually impossible for the attacker to steal that refresh token from that worker environment. That's a good approach. That's a good solution. However, like I said, not an easy topic. We still expose the access token in step 5 and 9. So if malicious code runs in the application's context, it can still intercept and steal those access tokens, even if you try really hard to not expose them. I actually wrote an article about that on my website, so you can look this up and find that. Even if you try to hide it, there will be a way for the attacker to override JavaScript functions through prototype pollution and steal that information one way or the other. So brings us back, we're going to go backwards one step to takeaway number 2. If you can think of something, the attacker can likely do the same thing in their code as well. It's really, really, really hard to isolate tokens within a JavaScript environment if you don't have browser-enforced boundaries like the web workers boundary in our example from before. It actually gets a little bit worse, because if the attacker can do all of that stuff, what else can they do? And there's a scenario that quite frankly scares the crap out of me, where the attacker doesn't even touch the legitimate application's tokens. So your legitimate application, your front end, handles running of an OAuth flow with the authorization server. That's step 1. Well, in reality, step 1 is actually like 15 steps or something, but don't worry about those in practice. But in the end, the application is going to get tokens, maybe with the SDK and the web worker and fully isolated and so on and so on. However, during that process, during that flow, somewhere the authorization server has stored a cookie in the browser to enable things like single sign-on and remembering a session and so on and so on. So that's the authorization server where the user would have authenticated. That one still relies on cookies under the hood to keep track of a session one way or another. That's the legitimate setup. That's how all of these OAuth and OIDC implementations work in practice. Now, our attacker. The attacker injects a piece of malicious JavaScript code. Remember, the application is doing its thing. It has an access token and a refresh token, but the attacker is like, yeah, I don't care. You do you, I'll do my thing. And the attacker in this case will set up a listener to receive messages from a frame. That's a technical detail. And it will run a new flow in a frame. The frame is the box here. That frame is hidden. It's called a silent authentication flow because it's a background frame that's invisible to the user. And in that frame, the attacker will run a flow with the authorization server. And in step 4, there's something very crucial happening. Because of how this protocol works with the cookie kept by the browser will include that cookie in step 4. That's how the authorization server knows who the user is. When I'm running this in my browser, I'm going to authenticate as Philip in step 1. And in step 4, the authorization server like, I know who you are. You were Philip 10 minutes ago. So welcome back. And it's not going to ask me again. It's just going to return tokens, well, a code, which are tokens, and so on and so on, giving the attacker a new set of tokens in step 6. That's basically what happens here. Because if you can do it, the attacker can do it. That's the key takeaway here. If you can do something, like running a flow in an iframe to get tokens, which is supported by OAuth, the attacker can do the same thing, and there's nothing you can do to stop that. Key takeaways, 3 very important things. Malicious code can do a lot more than a single action. That's a very, very common misconception, even in a world of OAuth where a lot of smart people are building specs. Even there, defenses often focus on this one problem instead of looking at the bigger picture of what malicious code can do. Malicious code can do anything a legitimate frontend can do. Anything you can think of is possible. The best piece of advice I have here is focus on cross-site scripting mitigations, prevent the execution of the malicious code in the first place by following secure coding guidelines and applying defense in-depth mechanisms like trusted types and content security policy, and so on and so on. All right. Well, I'm not done yet. This would be a very depressing end. So these were the key takeaways so far. I have one more topic I want to discuss, which gives us a bit more hope towards the future. So how can you handle tokens securely in a front-end application? Well, honestly, you can't. That's the conclusion here. You cannot do this because if your application runs JavaScript code and the attacker runs JavaScript code in the same environment, there's no way to isolate these from each other in a practical way. So the solution that we often use in practice for sensitive single-page applications is to not handle tokens in the browser. We keep them on a server component, which we call a backend for frontend, or a BFF in short. And a BFF is a, I want to say dumb, but that's not the right word, a very non-complicated component that doesn't do anything business logic related. The only thing it does, it's kind of a reverse proxy between the frontend and the API. So our BFF becomes the client application in an OAuth flow. So it basically, that's the part that will request tokens from that authorization server and keeps those tokens in a secure location. Tokens are handled in the backend, much better security properties in the browser. You don't have to drop them in local storage or whatever. And what's even better is the refresh token used in this scenario can only be used by that backend application. Even if somebody steals it without the credentials of that backend application, that BFF, an attacker will not be able to abuse those tokens. Good. How do the frontend and the BFF communicate? Well, you typically run these in the same domain. Restaurate.com/BFF would be an endpoint for the BFF. So if it runs in the same domain, you can easily use cookies to track state. And cookies doesn't necessarily mean it has to be a stateful backend application. You can also use encrypted cookies that store data on the browser. What's important is that this BFF is the only one able to extract the data from that cookie, validate it, and use it in practice. How would you send a request to an API? Well, the front end sends it to the BFF in a request carrying a cookie, and the BFF will unpack that cookie, find the tokens, use or make sure the tokens are valid, and then send a request to the API. That's essentially how this would work in practice. And the response from the API, of course, would be propagated back to that front-end application, making it possible to do whatever it wants to do. And in a nutshell, this setup, this scenario, doesn't really change much on the front-end side. Actually, your front-end gets easier. You can take out the OAuth stuff, throw it away, and change the endpoint for your API calls, and that's it. That's the only thing you have to change. Everything else remains the same. And on the API side of things don't change either. The API all the way on the right just handles a request with an access token, just like it did before. And the authorization server doesn't really change. It's a different type of client, but that's just a matter of configuration. So all we need is a simple BFF component, well, simple, this BFF component that is able to translate a cookie value into an access token, essentially. Brings us to takeaway number 4. BFFs keep tokens out of the browser, which significantly increases security. That's the reality. Yes, it's less fun. Let's use the nice word here. Less fun to build a BFF and deploy that because it's an additional component, but it's also not a very complicated or large component. And it's a component that can be easily reused across different front-end applications because it always does the same thing, basically. There's one attack vector that doesn't go away, and that's a session writing problem. That's if somebody injects malicious code into the front end, they can still send requests to the BFF pretending to be the legitimate application. That's the same challenge we had with cookies before, and that's a challenge we can't solve in any way. However, with that said, what happens in this setup is that all requests have to go through the BFF. So you have an additional point of control that can observe all requests. So it could see weird things. If the application sends requests like once every 10 seconds, and all of a sudden you get a burst of requests for 10,000 requests in 5 seconds, the BFF can assume that something is wrong, that maybe somebody's trying to extract data from the API or something like that. And that would be a way to detect that and maybe prevent that from happening. So the BFF reduces the attack surface, but it never takes the session writing problem away altogether, which means you still have to focus on secure coding guidelines and defense in depth mechanisms. And that brings me to the real takeaways here. If you're building a non-sensitive single-page application, I would say you can handle tokens in the browser. The approach with refresh token rotation, it's not bad. It's just not as secure as we would like it to be. So if you're building something non-sensitive that doesn't handle personal data, financial data, whatever, then sure, just use the best practices for OAuth and you're good to go. If you're building something sensitive, healthcare apps, business apps, something like that, strongly consider to keep tokens out of the browser with the BFF. It's the only real way of ensuring that malicious code cannot simply request new tokens and ship them off somewhere else. And thirdly, if you use a BFF, you can detect and block illegitimate traffic patterns. You can reduce the number of API endpoints that can be accessed, and so on and so on. So it gives you more control if you want to get that done in practice. All right. A couple of references to wrap up. The article I mentioned, the link is right here on the slides. There's also a link to a BFF middleware for .NET by Duende. It's a really good approach, a good library. So if you want to see a concrete implementation of middleware for building BFFs, definitely check it out. And if you want to learn more about the intricate details of OAuth, and trust me, there are a lot, I also have an online course that you can join to learn all about the current best practices for OAuth and OIDC in single-page applications and in API world. And with that, I want to thank you for watching. I want to invite you to connect with me on Twitter and LinkedIn. And if you have any questions, you can always ask them in the conference environment after this session. All right.
Hello, everyone. Thank you for joining. My name is Itai Shakuri. I'm the director of open source at Aqua Security, and I'm here today to talk to you about runtime security using a couple of very exciting technologies, eBPF and OPA. And I want to start this talk by actually sharing an example. This is a real example, actually, that our research team at Aqua has discovered. So this is a Docker image on Docker Hub that was doing something useful. Maybe you've even used it. And if you have used it, you probably scanned it, because this is what we do with container images. We scan them for vulnerabilities, for misconfigurations, for known malware, and so on. And if you would take that image and scan it with any popular static image scanner, it would be all green. All the tests would pass, and it would be seemingly innocent, except it won't, because it would try to do something bad once you ran it. And the reason is that there was a malicious binary hidden in the entry point. Now, this sounds very sophisticated and maybe challenging, but actually, if we take a look at the entry point, and you can see it right there, so you see this weird-looking string here that you may recognize as a base64 encoded artifact, and you can see the following line, which basically decodes this string and then executes it. So it's a pretty simple, even disappointing kind of techniques to hide something, but it was extremely effective because it managed to evade pretty much every static image scanner due to the simple fact that this malicious image was not existent at the time that the container was scanned. It only kind of appeared at runtime after the code in the entry point was executed. And my point here is that static image scanning, when we discuss it in the context of container security, it's a staple of container security. It's something that we've been doing for a lot of time, and it's a really important practice that we have managed to adopt, but it has its blind spots. And by simply relying on that tools, we were also overlooking some entire categories of risks, actually, such as the one that I just demonstrated. Which brings me to discuss runtime security. So runtime security is kind of taking the opposite approach. Instead of shifting left, we're trying to shift right and to look at the workloads, at the containers while they run. And this is the conclusion that we reached earlier by discussing that example, that the only way to really know what the container is going to do at runtime is to run it, right? So this is what we're going to do. And when we run the containers in the production, what we're trying to do with this runtime security solution is to detect suspicious behavior at runtime. This is the goal that we're trying to achieve here. This is what the solution that I'm going to discuss today is going to help you achieve. And we have a project that is called Tracy. It's an open source, completely open source, no secrets there, completely free on GitHub. So if you go to github.com/aquasecurity/Tracy, you can see everything about Tracy, how it works, what it tries to detect and how. And throughout this talk, I'm going to introduce you to this tool and specifically how this tool leverages eBPF and OPA in order to achieve runtime security. Okay, so let's discuss runtime security architectures in general, even regardless of Tracy. Pretty much every runtime security solution will have the following architecture, where there are two components basically at play here. One is the monitoring part. This is the part that deals with monitoring everything that happens on the operating system, right? We are trying to protect our servers, our production probably. So we will install some component onto that servers that will have visibility into every single thing that happens. We want to capture as much information in as much detail as possible in order for us to make detections later on. So that part basically just produces raw data, a lot of events. And then we take those events, we take this raw data, and we feed it into the other component, which is the detection engine. This is a separate component that is looking into that stream of events, and it is trying to find patterns, suspicious patterns, based on predefined rules that we will give it. So there are rules that we ship with Tracy. You can write your own rules as well, but basically you give it something to look for. You kind of teach it what a suspicious pattern might look like, and then it looks for those patterns within the stream of incoming events. This is a very, 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 very high level overview of Tracy, or a runtime security solution. And you know the title of the talk, so you know that there are two core technologies that play here. One, eBPF for monitoring the operating system. So eBPF is a very exciting Linux technology. It's part of Linux, part of the Linux kernel. And in a nutshell, it allows us to instrument the operating system and attach to very interesting points in the kernel workflow, and actually execute our own code in there. So this is actually the uniqueness about eBPF, that it allows us to run our own code there, so that we can collect whatever information we might need, and we can do it in a very safe and reliable and performant way, so that you will not be affected by this overhead. I'll talk a little bit more about eBPF soon. And the other technology that is helping us build Tracy is the Open Policy Agent, or for short, OPA. OPA is a graduated CNCF project that deals with policies and policy enforcement. It was meant for scenarios like authentication, authorizations, so you can define the rules, the policies that you want to enforce, and OPA gives you the language, first of all, to describe those policies, and then the tool to enforce them. Another popular scenario that we see OPA at play is with Kubernetes, for example, as an admission controller. So it will receive all of the user requests to create resources in Kubernetes, and you can define policies of what kind of things you want to allow or to deny, and OPA can help you enforce that. We use OPA slightly in a slight creative way, because we think that the incoming events, we see them as input documents, and we express OPA policies to help us look for the specific patterns that we want to look within those events. And we will also see, talk more about OPA and see an example for that later in the talk. All right, so what we're going to do next is to zoom into each one of those components and see them at play. Let's start with the first one about monitoring, the monitoring component. And to discuss that, we first need to understand this mental model of how the operating system works and what it means, basically, operating system tracing. So this is a very common common diagram where you have your application, it's running on the computer. There is hardware to the computer, right? And your application is trying to make use of it. Let's say it's trying to create a file, or it's trying to communicate over the network, or whatever it needs to do with the computer. Actually, the hardware itself is inaccessible to the application directly. In every modern operating system, including Linux, the kernel, which is the component of the operating system that is in charge of managing the hardware, is the only component that can actually touch the hardware. So the kernel is the only way that we can touch the hardware. How can we do something simple like open a file? Because the file exists on disk, we need to interact with the disk somehow. So the mechanism that operating systems lets us communicate with the hardware is via system calls. System call is a common interface where the kernel exposes these system calls. Basically, think of them like functions that you can call from the outside. And by calling a system call, let's say the open system call, which is a real system call in Linux, you can ask the kernel to open a file for you. So let's go through these layers from the top to the bottom. You, the application developer, or someone who uses an off-the-shelf application. The application is trying to open a file. Probably the coder, whether it's written in any language, Node.js, Python, C, it doesn't really matter, is going to use some library that will call into another library that will call into a lower level library, which will eventually call a system call. And that system call will be handled by the kernel. The kernel has access to the hardware, and via probably some device driver will actually move the needle, read the bytes, and return the result to you. And the reason that I'm sharing this at this moment is to show you exactly where eBPF fits in. eBPF lets us plug right there between the system call and the kernel. And this is the perfect place for us to be if we want visibility into everything that happens on the computer. Because it doesn't really matter whether the application is written in whatever language, whether it's running in a container or in a VM, or whether it's privileged or not. None of it matters. All of the code that is being executed on the computer and is trying to access the hardware is going to eventually go through us, thanks to eBPF. And this is where we have the opportunity to examine what's going on. But more than that, unlike other instrumentation technologies that lets you just log the calls, in this case, we can actually run our own code at that point. And our code, by the way, runs in the kernel. So we have a lot of visibility into everything that happens at that point. We can collect additional information. Collect additional information and provide a lot of contextual information around the raw event. And this is what helps us create very high quality events with accuracy and reliability. And the result of this is that the eBPF probe, this thing that we send into the kernel to help us collect the data, will tell us, yeah, an open system call was detected here, and this is all of the information that I can extract at this point. All right, so this is operating system tracing that we can achieve using eBPF. We discussed system calls. There are a lot of system calls in Linux. And the good news is that Tracy allows you to trace pretty much all of them out of the box today. I counted it just before this talk. It was 353 system calls that we support in Tracy. It's a lot. It gives you everything, all of the information that you may need in order to make quality detections later on. But the interesting part is that on top of those system calls, Tracy also gives you access to other kernel events. These are specific points within the kernel that we chose to instrument manually in order to give you more information that is more meaningful in a security context, because this is where we are at. We're trying to detect suspicious behavior. So those other kernel events, which I will demonstrate in a second, will give you access to more reliable information, more accurate information, and more secure information. And we keep adding more events to Tracy every day. Probably by the next time you'll see this recording, the numbers will be different. But what I want to do next is to demonstrate what Tracy eBPF looks like. By the way, in the Tracy code base, we actually keep it that way, that the monitoring part is separate from the detection part. So we call the monitoring part Tracy eBPF. And yeah, and now we can see it in action. All right, so I moved over to my terminal here. And Tracy eBPF is now an executable, is a command that you can run. And I can tell it, first of all, to just list all of the events that it can trace. So what you see here is a huge list of all of the system calls and other kernel events that we can trace in Tracy. And for each one of them, you can see what kind of information you can expect to receive from this event. Let's start Tracy with no arguments, which will start a general purpose trace. It will just try to trace everything that happens. And you can see already that things are happening here. Maybe try to open a file here and you can see more things are happening. Let's stop the trace. And just in a couple of seconds, we captured almost 150 events. And this is because, you know, it's a Linux machine, it's alive, it's doing things all the time. And we can see a glimpse into what we were able to capture here. At what time, what user, what was the command, process IDs, what is the exact event, and the arguments of that system call. For example, we can see an open system call. Open@ is a variant of open. And you can see all of the arguments that were given to this system call. And you can use this information to do very interesting investigations. Let's do something else. Let's ask Tracy to trace just the open@ system call. If we do that, oh, sorry, I forgot to add an event. I want to ask Tracy to trace events of type open@. And now we see slightly reduced output, still quite verbose, but slightly reduced. Actually, let's add another filter here. Let's ask Tracy to only show us the output of the cat command. All right. And I'm doing a cat down here for a file, and you can see now a more digestible output. These are all the open@ events that happened from this cat command. You can see it trying to open some files, eventually also opening the test file that I asked it to open. And this is a good opportunity to also mention the other events that we add on top of system calls. Open@ is a system call. And you can see here that you get access to the real information that was given to the system call. In this case, test, just the name of the file. But there are many different ways to access a file in Linux, to reference a file. So for example, you can say the relative path, the full path, you can give it a DRFD that changes the way that the path name is handled. You can give it a file descriptor that is already opened. This is Linux, so there's a lot of flexibility. But what I can do here to make the output more usable is to add the security file open event. This is an event that Tracy is introducing on top of the open system call. And I want to show you the differences. This is the open@ system call, same one that we've seen earlier, that shows us the output of the tests, the opening of the test file. And this is the security file open that gives us the resolved file path to the real file that was opened. So this is much more usable for us if we want to make some kind of assertions on this output in order to make detections. Moreover, this event, the reason it's called security is that it is more secure. I won't go into that. We've written a very detailed blog post about that in the Aqua blog, but system calls, because they sit in the border between the user and the operating system, the user has some influence on what they pass to these calls, what kind of arguments and when, and it is vulnerable to some kind of attacks, while the security events, which generally called in Linux LSM functions, are not. So it's not only more usable, it's also more secure to use this kind of events. I could also ask Tracy to output to format the output as a JSON, and I could pipe this JSON stream into other tool that will, look into, for example, the args. You see here the args property, and we can look at the second argument here, and you can further play with it and create your own kind of detection logic. But we'll see that there's a much better way to do that soon. All right. So that was a quick segue just to show you what the raw data looks like, the monitoring part of the runtime security solution of Tracy. Let's move on to discuss the second component, the detection component, the detection engine, like we call it. So we're now zoomed in to the detection part. We have on the left events flowing in from Tracy eBPN. This is raw data, as we've seen. And on the right, we will produce detections. These are alerts, actionable alerts that the user can process. So we've seen an example of how an event looks like. I'm just formatting it here as JSON document, so it's easier to reason about. And we have access to all of this information. We just need to know what to look for. So this is where we are using the Open Policy Engine. More precisely, more accurately, the Open Policy Agent, the language that you write policies in is called Rego. So technically, our rule engine is able to process Rego signatures. This is how we call them, Rego signatures. And it looks something like this. So we ship Tracy with a bunch of Rego signatures for you. You can also write your own. You just create a new text file. It looks something like this. And let me just bring the pointer back. You create a text file. You can declare some metadata for prettier output, but the interesting part is this block here. You create a rule that is called Tracy_match. And within this rule, you just give us a list of conditions that needs to be matched in order for this signature to detect. So think of it like a big if-else statement where you are only required to provide what's inside of the if. What are the conditions that you are interested in? And you have access to the input here. So you can say things like input.eventName. This is the name of the event. So input.eventName, let's see if it equals to openet. This is the system call that we're interested in. And then let's see if the input has an args field, which it does, and it's an array. So let's just run through all of the elements in this array and look at the one called value. Look at the field called value of every one of those elements. And let's call this file path because we know this is what it represents. And then let's see if this file path equals to etc shadow, which is a very well-known file that you don't want to manipulate with too much. If you do see this file being manipulated without your knowledge, then it's probably malicious. So this is a very simple detection that will detect that. But what I want to show you here is really the simplicity of writing a new rule or a new signature for Tracy, and it all really thanks to OPA, thanks to Rego. Writing something like this in code would probably result in I don't know, 50 lines of code that with a lot of loops and a lot of checks and a lot of stuff there. Here it's just 3 lines. You know, we just assert that the event name is OpenNet. We just implicitly iterate and look into the elements and then do another assertion, and that's it. Pretty neat, I think. Yeah, and what I want to show you now is example for signatures that we have in Tracy. So I'm going to move over to my browser here. And this is Tracy on GitHub, aquasecurity/Tracy. All the code for the eBPF part, the monitoring part, and the rules part is here. I'm going to click into the rules part and signatures, Rego. And you can see a few Rego signatures here. We keep adding more and more. And let's look into, for example, this signature. I chose this one because this one is maybe the most complicated one that we have, but it's still pretty simple. So it's really demonstrates the readability and expressiveness of this signatures language. So it's a text file. You declare some metadata here just so that the UI can show you something helpful. You tell us what kind of events you are interested in subscribing to. And this is the boilerplate. And then you can see these Tracy match blocks. There are 3 here because this is a code injection signature, as you can see here. And what it is looking for is indications that someone or something tried to manipulate a running process at runtime. And there are different ways, different techniques to do that in Linux, right? Our research team has researched and investigated the different ways that someone might be able to manipulate a running process's image at runtime. And it came up with these 3 ways. So they just wrote them down, codified them as Rego code. The first one is using the ptrace system call. So we see if the event name is ptrace. We look at the argument called request, and you can see here a slightly different way to do that. We also provide helper functions, Rego helper functions. So you can ask something like, give me just the value of the request argument without writing that more verbose code that you've seen earlier. You get the result and you see whether the ptrace request is ptrace poke text. Poke text means that someone tried to manipulate the code of that program. If it did, then it's clearly a code injection behavior. And there are other behaviors here. Let's see a more complicated one. In this case, we're interested in the security file open event. And we want to see if the opened file looks something like this. This is a regular expression. So if the file being opened is /proc/pid/mem, which is a special file handle that Linux offers to manipulate the memory image. And we also check whether it was opened for write and not for read. And if so, it's a detection. Here we can see another cool thing, not only other helpful functions and so on, we also see that you can also return a result from the detection. It's not just a true false. Yes, there was a detection. You can also give us some evidence give the user some evidence into what really happened. And there are many different ways, so we're not going to cover all of the signatures. Just wanted to show you a real world signature that is one of the more complicated ones, but I think it's actually pretty readable and approachable. Okay, moving back to the slides, we have covered the monitoring part, we have covered the detection part, and now let's zoom out and review the solution end-to-end. We have the operating system, which we now instrument using Tracy's eBPF probe. This is the probe that we send into the kernel to report back to us about everything that happens. It reports it back to Tracy eBPF, which is the component that is in charge of monitoring. Tracy eBPF is then continuously generating an endless stream of events that represents everything that happens on the operating system. And this raw data is being fed into the Tracy rules engine. This is the rule engine, which is loaded with Rego policies, Rego signatures. Each one of those signatures is always looking for a suspicious pattern. And if one of the signature has found that pattern, it will create an alert. The alert that the detection itself is human readable, is actionable, unlike the very verbose raw data. This is something that you should understand and you should be able to respond to. And you can also ask Tracy to send this event to you in whatever preferred way you have for communication. So you can ask Tracy to send a message over a Slack channel, send you an email, open a Jira ticket, whatever, using a very flexible webhook interface. And this is how the runtime security looks like end-to-end in Tracy. And just to finish that demonstration, I wanted to show you that in action. Actually, I'm going to move over to our documentation very quickly, which is linked to from the GitHub repository. And I'm just going to copy this line over here. This is the quick start example of how to run a Tracy altogether. So this Docker container, aquasec/Tracy, includes Tracy eBPF and Tracy rules and all of the signatures that we ship with Tracy, and it is set up so that it sets everything up so that you immediately start monitoring and detecting things. Let's just run it like this, and you can see that it has loaded some signatures. And actually, what I want to do now is to execute this test file, and you can see that Tracy has detected something. This is a standard input-output over socket, which means that Tracy has detected that someone has redirected the input or output of some process into a remote endpoint. And it even gives you the remote endpoint that we detected and what was the command, what was the container name, and so on. So this is something that you can actually understand and react to and hopefully mitigate. All right, great. So I hope that you learned about runtime security today. I invite you to go over to github.com/aquasecurity/Tracy. We have discussions over at GitHub. So if you are trying out Tracy, you have a question, you have a suggestion, you just want to reach out and say something, please go to our discussions area and start the discussion. We'll be happy to talk with you and try out Tracy. Give us a star and tell us what you think. If you want to get in touch with me personally, you can find me over Twitter at itaysk, ITAYSK. And with that, I want to thank you. I hope you enjoyed this talk, and I hope you enjoyed the rest of the conference. Thank you.
Hey, welcome back.
Hello again, Brian.
Hey, Matt.
Feel like deja vu.
Yeah, we've been doing this before, right?
Yeah, I'm sure we have been here before. Although our tireless backstage crew have now been working for almost 24 hours straight. So
big shout out to them. Thank you, Sam. Thank you, Patrick, for doing this and keeping up with us as well and our silly jokes. Well, we promise not to make jokes today. So we had just had 3 sessions had in the clouds, automating cloud security and auditing by Natalie and Max. After that, we had token security in single page applications by Philippe. And just before this break, we had runtime security using eBPF and OPA by Itchy. What was your favorite so far, Matt?
Runtime security. I'm really interested in eBPF at the minute. I think it's a super interesting kind of emerging technology. I don't know whether you're familiar with it, Brian. There's a great O'Reilly book that you can buy all about eBPF, but it's a set of programmable functions in the kernel that let you have access to all sorts of underlying information that the kernel has about what's going on in the system in real time. So if your applications start misbehaving, you can actually look for patterns of anomalous behavior using eBPF. So there's some very cool tools out there in the cloud native community like Falco, which allow you to take that data and use that as an extra layer of security for your applications. So I think runtime anomaly detection is going to be a real emerging area in the future for looking at cloud native applications. As well as being able to check things before we deploy them. We can see what things should be happening under normal circumstances and detect when things are starting to do things they're not supposed to do, whether that's accessing files, accessing different parts of the network or whatever. So I think it's super cool. I encourage everybody to go out there and read up about it. It's great stuff.
Yeah, for me, a lot to learn. I am still on that application creation site and do it all on forehand. So probably some interesting stuff for me as well. I did saw part of the talk, so I already engaged with it. That I have to look into that more and more to broaden my horizon, so to say. I like the talk before that by Philippe about token security and single page app, because it's basically something that as an application engineer you do. Well, it's something that you do naturally, and you do not always have attention on what goes wrong, how you can fix certain things, but also that are some things that you still cannot fix that you have to just be aware of and do some sort of best effort on that. So I like that. I like the talk. And personally, my favorite, but it was all at the beginning and the APJ part, was the talk about I Spy by Rosemary, a developer advocate from HashiCorp. If you haven't seen that one, just please look back. And I know that all the talks are uploaded and will be available soon for everybody who wants to see them or review them or review the examples that are used in any of the talks. So don't be afraid. You can watch everything back.
So have you been hanging out in the DevSecCon community on Slack today, Brian?
Yep, I've been reading a lot, saying hello to people, meeting old friends. It's always fun to do that, and that's part of the community as well. That doesn't always have to be technical. It's good to see that a lot of people want to do ask questions on that. And well, I don't know if it was on one of the channels. I think it was a private channel here. I got a shout out that I did say something wrong in the last break. Like I said that we do some award stuff at the end, but it's not, and I said it wrong. We are looking for nominations. So if you have nominations for the DevSecOps Leadership Awards, and we will award these awards, or we will give away these awards during DevSecCon London. And
right, we should both read the script. Really, Brian.
I should.
I also got that from the script, or perhaps we need to speak to the script writers.
Yeah, Sam. Thank you. No, I'm not. But if you have an award or you think somebody should get an award for a DevSecOps leadership thingy, make sure that you nominate that person via our DevSecCon website. and you can. I believe there's a form over there. I'm not exactly sure where it is. I know it's there. I've seen it, but yeah, do that. Please do that, so we know who the great leaders are that help us out.
So for folks who haven't joined the Slack community yet, where's there's a button on the website, right? Do you want to point people to that again and just show them where that button is?
Where is the button? I need to share my screen. That's always the worst thing of doing things live and unscripted. Brian, can you show this? Probably. So let's just.
So in the meantime, it's worth pointing out that obviously the DevSecCon Slack community is not just about this event, although for all the DevSecCon events, we have channels in that Slack for folks to hang out, chat to the speakers, chat to each other. But it's a great place to network on an ongoing basis with folks from across the DevSecOps community.
Where's that button?
It's up the top, Brian. I think
it's at the top.
On DevSecCon.com, I think is the
DevSecCon.com. Yeah, of course. This is the event page. And join our Slack.
Blue button up there. That's it.
There you can see it. Like join our Slack. I can make it larger. That doesn't help for anybody, but that's where you join the Slack.
And while we got the browser up there again, Brian, should we just show everybody once more how to go and visit our lovely sponsors, without whom none of this would be possible? You can go and chat to those folks about what they do, about how they can help you, and access loads of other cool content that they've got playing in their booths. So if you click on the sponsors link there, that'll take you through to the virtual sponsor area, where you can visit a whole bunch of awesome folks and check out what they are doing.
Let's just do something, a random one. I'll see if they're on board. They're actually doing something or not. I'm not sure. Oh yeah, now I need to.
There we go.
Let's not do that. Let's not interrupt.
Let's not waste their time thinking that you want to go in there.
Yeah, exactly.
I'm sure they've got important folks to talk to, Brian, rather than
actual conversations instead of me rambling around. So yeah, the sponsors is an important part. The community, you saw already that we can that you can go to Slack for that. Please do so, because I feel like engaging with other people is the most important part of a community. Anyway.
Yeah, absolutely. I mean, that's what I really miss from being at in real life conferences, Brian. Right, is the hallway track and having a chance to chat and network and learn from other folks in the community. Hopefully, we'll get back to that pretty soon, right?
Yeah, hopefully we will. I believe we will. But now we have the agenda up. Let's see what's coming up next. Introducing graph theory to policy as code. I'm always intrigued by graph theory. It brings me back to my university days. So that sounds interesting. I have no experience with it, with the graph theory and policy as code, but graph theory brings back good memories from university. Mobile decomposition. That's also an interesting one. Where are you looking forward to, Matt?
Well, I guess I'm probably gonna try and watch both of those. As it's the last two of the day. Graph theory always sounds like it's for people who are a lot cleverer than I am, but we'll see.
Yeah, hopefully I understand. That's what I'm afraid of. That I can understand what they actually mean. But I've seen the abstract, and I believe it's an interesting talk. So definitely we'll go there. Let's finalize with some other things. Well, we already talked about the sponsors and the community. If you go into a session, you can rate every session. There are stars in every session, and let's.
Yeah, that'd be great to get feedback on that, both for future conferences and for the benefits of the speakers there. Everybody loves getting feedback to see how they can improve for the next time they go out and give a talk. So only 2 stars for us this time, Brian. We're getting worse. I'm sure we had 5 this morning.
Okay, I give it a 4-star because you forced me to do something, which is good to some extent. But yeah, you can rate the sessions. Please do rate the session and give feedback. Not only rating in the amount of stars or the amount of hearts in this case, but give feedback what you like or what you disliked about the talk, so we can provide that back to the speakers, so we can have better content next time, either DevSecCon London real life, but also the next DevSecCon24 virtually. So please do that.
The talk has 3 super easy parts. The first one, we'll talk about what is policy as code. Then we'll go to a crash course on graph theory. We'll try to simplify it so nobody will panic about combinatorics or mathematics. And we'll go a step deep into Chekhov's internals and see how graph queries are working for it. So I thought for a while on this talk, and since it has policy as code in the title, I thought that it would be matching to discuss a little bit about the history of policy as code the way I have captured it. So it's very biased and it's on a non-linear timeline. But since I've been working on YAML stuff and trying to make YAML stuff be exciting for the past few years, I thought to give it a shot. So for me, if I'm trying to tell the story of the evolution of policy as code, it's really a set of stage phases. I met them first as a software engineer in a big enterprise, and then I encountered policies again in startups and other big enterprises that I had a chance to work in. At the beginning, everything was very manual. Businesses, committees, and regulations came together to create a set of best practices to secure data centers or cloud environments and the applications that run on top of them. After a while, enterprises have started to work with auditors to enable expansion of business and make sure that the right methodology and controls are in place. Best practices and reports like ISO or SOC 2 Type 2 or PCI, if you are a company that works in the fintech area, have started to take place as industry standards. Auditors have started to ask things like, where do you store your data? Who has access to the production environment, and what is the process to gain that access? Are you following secure development principles like OWASP Top 10? And it was good. We started to have a discussion on what should the market look like? What should be the best practices for security? And that was the job of the auditor to help us make sure that we have all of those best practices in place. And it was the job of the director of engineering or CISO or CTO or CIO to answer all of those different questions of, is my environment following a set of best practices? And in the beginning, it was very manual. I really did not envy the director of engineering that should have answered all of those policies. It was a giant piece of work, spreadsheets over spreadsheets of policies. The ment was good. We wanted to be more secure and be compliant with best practices and to enable our business to grow to other dimensions. But it was very tedious and boring tasks. The good thing about it is that smart people got opinionated and have evolved those policy papers into online documents in things like Confluence. Information security practitioners have wanted to create the policies that are best matching their organization risks. So started to do threat modeling, and they wanted to collaborate with other teams or within the team and have the ability to integrate that to a ticketing system like Jira. So they've created an editable, shareable, collaborative document in Confluence or internal wiki with the policies that are relevant for your org or application by the threat model that you have in your org. And it was integrated to Jira natively, so you can convert a policy into a set of tasks that are managed by the IT team or SRE or DevOps. Soon people realized that maintaining such a set of policies can be hard, disruptive, and very manual task. So you get more good people on that topic, more smart people that will try to automate that process and have continuous auditing on those policies on top of the data centers and cloud environments that you have. So those smart people have started to create scripts. We could start seeing basic automations for scanning policies on top of the running environments. Those scripts were running on hourly or daily basis, and they were making sure that things like VMs, databases, serverless functions, and their networking configuration are compliant with the best practices. And if not, automatically create a Jira ticket and assign it to the matching owner within the engineering team. So this helped the cloud security team or the information security team to scale and always audit, always on all of the different running servers. But it have inflated the SRE's team's backlog with endless tasks on top of resources that were already deployed and they were already out there in the AWS, GCP, or Azure account. And when SRE teams have transitioned from provisioning resources manually through the different consoles of the cloud provider to infrastructure as code, pushing different versions of microservices multiple times a day to production, the solution of monitoring the cloud environment after resources were already provisioned took too many times, a lot of effort, and had too much friction. So you take another group of smart people and you ask them to create a linter. The different manifests languages, the different configuration as code languages like Terraform, CloudFormation, ARM template, serverless, and Kubernetes, and even Helm charts and Kustomize, and before that, Ansible, Puppet, and Chef, have introduced us the capability to actually unit test before resources are provisioned and as part of the development lifecycle, those same policies, making sure that a resource is encrypted, that the right IAM, identity and access management policies are in place before anything is getting provisioned. So some policy as code engines came out to the world. Two popular ones is OPA, called OPA, by the CNCF, the Cloud Native Foundation, and Chekhov by Bridgecrew. So hi, I'm Barak. I'm the maintainer of Chekhov, or one of them. And we're going to focus on that and some of the things that we've learned along the way. So the idea of policy as code is that you write in high level in code in Python or YAML or Rego in text files, the policies that you have. And you can use those policies and store them within a version control system. Use automated testing of them, automated deployment, peer review them, etc. So we took the different policies as code and we will see one example, and it has some other advantages. You can also integrate policies as code engines into your CI/CD pipeline, and it will help you to inspect the different manifests before provisioning the resources into the cloud, or even run them as a pre-commit hook or an IDE plugin to review automatically a set of best practices and make sure that your code is compliant. That way, we have distributed a lot of the manual tasks that were previously been done by an auditor and then reviewed on running environment to something that is really part of the development lifecycle. The reason that we've done that is that what we like the most as engineers is when we have a task to get done with it and to move to the next one. It's really bugging to return again and again to the same tasks and fixing stuff. You just want to move to the next interesting topic that you need to develop. So Chekhov was built to inspect and do static analysis of infrastructure as code on manifests like Terraform, CloudFormation, serverless, Kubernetes, and others. It has a pretty good coverage and more than 100 different open source contributors. So let's do a quick install of Chekhov. So what we'll do now, we'll pip install Chekhov. I've already done it on my host. And I have a Terraform code for an S3 bucket. I'm going to run this Chekhov command that will verify if my S3 bucket have backup and recovery in place, meaning having versioning in place. And I see that it doesn't. How does this policy look like? It has a section of metadata. which includes the name of this policy. Ensure that S3 buckets, which is an object storage, have versioning, which is a backup and recovery configuration for it. I gave it an identifier. I told Chekhov what resource to inspect in code. And I've also told Chekhov what attribute to inspect. I told Chekhov that versioning should always be enabled for my S3 buckets. So from now forward, on every time that I'll try to add or modify or scan an S3 bucket on top of defined in code, in Terraform code in my case, I'll understand that the lines that are missing are actually versioning being enabled. If I'll add that, I can pass the test of Chekhov. So Chekhov has about 800 different policies that were contributed by different companies from the community, and you can enjoy those inspection of your code automatically. The thing is that on Chekhov 1.0, we were only able to do attribute inspections. What does that mean? It means that we know to go on top of a configuration and ask, does an attribute equals a value, or set of attributes equals a value? But the thing is, environments are more complex than that. So the story of evolution is really about the productivity of authoring the compliance of our cloud environment, or the best practices that we have in our cloud environment, or internal policies that we have on our cloud environment. But it's all about productivity of those manual tasks. We increase the level of automation of policy auditing in each step of the way, starting with the basic policies dictated by the market best practices, and going forward to custom ones that we have decided that are relevant to our own organization based on a threat model that we've done on our data center, AWS account, or application. And from there, we're making sure that a linter is assisting the development teams to handle misconfigs faster and in an easier way. But as I mentioned, it gets more complex than that. Modern cloud infrastructures are having a lot of microservices. Resources depend in each other. You will often see a compute resource that is attached to a networking configuration, and that's attached to an RDS, a database, and that's attached to a storage mount, and that's attached to an IAM policy. So all of those resources cannot work as a whole web application independently and give our customers a service. We need everything to be orchestrated correctly and be configured correctly in order to have a working cloud environment. So infrastructure as code projects such as Terraform or CloudFormation have built a data model called directed acyclic graphs to model relationship between resources. So operators of cloud environments can safely manage the change of infrastructure resources and their dependencies on bare metal, IaaS, PaaS, and SaaS. Let's take a look on a sample architecture. Here's a simple web application. That's crazy. It has a lot of moving parts. We can see here DNS helping us to match IP address to a beautified name in the web browser. A CDN for static content that is stored on object storage on S3. This is in AWS, this example. Serving us JavaScript files, CSS files, etc. An application load balancer, a set of compute instances with auto-scaling group, a queue, and a data pipeline that is managed on EC2 instances with access to RDS, the RDS backup, which is the database backup, and also those same compute instances responsible for data pipeline have a mounted storage of EFS. So that's a lot of moving parts. And we have a lot of policies that the market is telling us, hey, those are really the best practices that you should follow. So this specific diagram, or similar to it, was actually presented in HashiConf on 2016 by Paul Hinze. So a lot of this talk is inspired by his topic on graph theory. If we want to apply a policy on this infrastructure, we would probably ask questions like, is the file system encrypted? Or is the security group that is attached to all of the different instances has port 000 open to the world, meaning is my instances public? But the thing is, I don't really like to ask a lot of individual questions on EFS and security groups. The thing is that I want to understand from threat model perspective is there an actor that could access my EC2 instances, and does those EC2 instances has unencrypted volume, so that if data is leaked out, is it leaked in an unencrypted manner? So the actual query that I would like to do is a traversing query. I would like to ask, do I have a path from the internet into an instance through a security group and into an unencrypted bucket? So I want a query that is aware of the dependencies of my cloud environment. So we need a strategy to ask dependency-aware policies. And this is where the second part of the talk goes. I know that graph theory has discrete mathematics, combinatorics, and some complex math stuff, but we'll really simper it down in 2 minutes. Let's give it a try. This is a node. A node represents a code block. A Terraform code block can be a provisioned set of instances in the cloud environment, or it can be a configuration that is attached to those resources. And this is an edge. This is another edge. The edges represent a relationship between different nodes, in our case, in the cloud. A graph would be a set of nodes and edges that are attached to each other. So a directed graph would just mean this is the direction of the relationship between those different nodes. So a directed edge will give us a directed graph. And a directed acyclic graphs just means that I don't have circles between 3 nodes, for example. The next operation that we can do on top of a graph is actually a walk. Let's take a look on how our DAC walk. A DAC is our scanner, and it can walk through different edges by the direction of the different, walk through the different nodes by the direction of the different edges. It can actually perform actions like look for a connection between different nodes or scan their attributes. So it will traverse over the different nodes by a specific direction. It sounds reasonable, and we can actually apply it on an architecture like the following one, where each and every resource defined in this diagram is actually a node, and all of those dependencies are actually the directed edges between the different nodes. And this is how it will look in code. Over here, I have another example. I have an EMR cluster, a Spark cluster for the production data engineering team. This cluster is attached to a security group from development environment. And this security group, which is a firewall configuration, is attached to a variable that defines what are the allowed IP addresses or CIDR blocks to have access to that EMR cluster, networking access. And I actually have an even slightly larger code that defines 2 EMR clusters. We have our production data engineering one, and we have another one called data science. Each one of them is attached to a different security group, and one of them is attached to a variable. So this is my Terraform graph. These are the different dependencies that I have defined in code on top of my cloud resources. And the question that I would like to ask, or the policy that I would like to have, is to ensure that Amazon EMR clusters security groups are not open to the world, to the public internet. Or to simplify stuff, make sure I don't have public sensitive stuff out there. So I'll create a graph query. A graph query or a graph policy is something that we've introduced in Chekhovic's open source 2 under version 2. And we can ask complex queries on top of relationship between cloud and cloud resources, making it more matching to our threat modeling question that are asking not only if a resource is compliant, but is there a real risk? So over here, I've defined this policy of EMR that are not public to the world. I've defined a category, which is networking, and given it an ID on the policy metadata. The next part would be to define a connection block. So a connection block would be look for a connection that exists between two different resource types, EMR cluster and security group. If you have found one, move on to the next step, which is inspecting an attribute. An attribute block would inspect an attribute of one of the resources within the connection, and will check if the security group has on each CIDR block any value that equals the entire internet, 000. And filter is actually something that will make things faster for us. It will tell our traversing logic to focus on or to start traversing from EMR clusters. So if we have a huge graph out there of hundreds or thousands or tens of thousands of resources in the cloud, we can focus the query to start on the most matching place and traverse from there. And the last is I want to have an end condition between all of those different blocks of query. So how it would look like, we'll go from the EMR cluster into the relevant security group, and from there to the relevant CIDR block, and then verify if we have 00 defined. If we have, we're failing the policy. We have a public EMR cluster. So on the graph, I'll run a depth first search. It's a DFS algorithm that is used to traverse graphs or trees. The algorithm starts at the root node. It can select an arbitrary one, or it can be defined by a filter. And it explores the possible path on top of each and every branch to answer our query. So we'll go to this branch, the provider of AWS. From there, we'll go to the EMR cluster of data engineering. We'll go through the security group that is attached to it, and we've identified that we have a bad CIDR block, a public networking interface, public networking security group defined for the ingress rule. And now we'll scan if there are any other instances of public EMR blocks. We'll go to the second cluster, and we have identified that the second security group is actually in a good state. Let's take a look on the demo. I have another Terraform code, 2 EMR clusters defined, one for data engineering, another one for data science, with 2 different security groups, one for dev, which is open to the internet, and one for prod, which is actually segregated. I run checkup with a specific check ID that I've just defined, which is CKV AWS 7, scanning the local directory of Terraform, and I can see that I have 2 different clusters. One is fine and the other is not. So what just happened? Checkup have read the infrastructure as code that I have defined in my local directory or Git directory. It has created a directed acyclic graph that represents the same graph that would have happened after deployment in production environment. And on top of that graph, on top of that data model, it have executed 2 types of policies: attribute-based policies, like do I have versioning enabled for S3, and graph-related policies, asking about the relationship of 2 or more resources and their attributes, enabling us to ask more difficult questions like, do I have any public instances with unencrypted volumes, or public EMR clusters? So I can take checkup as if I did in locally, and I can actually put it as CI step. It can run as a GitHub action, a container, or a GitLab runner. Any way to run a utility, a container utility within a CI. So on every pull request to GitHub, Chekhov can actually run a set of security tests of policies as code, inspect our infrastructure as code, and if everything looks fine, we can trigger a deployment to our destination account or project between the cloud environments. And if we integrate that as a GitHub action, we actually have a failed state of successful or failed execution. So what other stuff does the graph abstraction enables? The fact is that the community is actually asking those kind of graph queries all the time, each other. Information security teams, networking teams, DevOps teams are asking those stuff to help prioritize what's the actual risk I have in my cloud infrastructure code versus what's just a compliance best practice. So example questions would be ensuring that we have volumes attached to EC2s and they are encrypted, having S3 buckets attached to public block access, RDS clusters that have backup plan defined, and even KMS keys, making sure that they do not have the ability to be read by anonymous user or are not publicly accessible. So those are different use cases that you can actually define in a graph policy because they cannot be defined on a single block, and they should be inspected by correlation of different code blocks that in some cases are scattered across multiple files or repositories, but in Terraform, they are dependent in one another. So the graph is actually giving us a solid data model and room to evolve. The community is asking for graph queries for years each other. So it's actually an opportunity for the community to contribute more and more policies into Chekhov as a shared hub of best practices. The graph query is a composable query language, so you can add more and more condition to it and make it more robust or inspect the right things that you care about. It's a composable data model, so you can actually ask queries in the future like, do I have public unencrypted container orchestrator like EKS or Kubernetes, and does it have vulnerable images? So it's also publicly accessible and exploitable. It can be integrated to part of the software development lifecycle like CI systems. So it's really an opportunity to correlate all of the important stuff in information security with the CI pipeline. And another example to the opportunity that the graph may give us is we can actually ask questions that correlates the code state, meaning is our code defined as secure infrastructure? And is it attached to a running state of cloud environment that is also secured by the same manners? So graph is only the beginning, and we are only in the beginning of the implementation of it within Chekhov, but it really excites me because it really has a lot of places to grow and a lot of application we can build on top. So I would be very excited to see you all contributing code to this open source project. And you're more than invited to give it a try or ask question on Chekhov's Slack channel or even ping me over email. Thank you again, DevSecCon. I'll be here in the chat if you have any questions, or you can reach out right after. It was a pleasure.
Hey everyone, thanks for coming. It's Grant here. Today we're going to be talking about mobile app decomposition. It's a pleasure to be speaking at DevSecCon. I was part of the panel last year, so it's good to be back speaking this year. And yeah, with that, let's get started. So yeah, today the focus is really going to be talking about mobile app dependencies and supply chain. We're going to talk about what apps are made of and how we can figure out what's inside there. We often know our own dependencies, but we don't necessarily know the complete picture, as we'll soon find out. And when we have a large set of components that make up our apps, there's a lot of risk that can be incurred to the business, not just vulnerabilities, but other risks like software licensing, compliance and other things. So we're going to go into a lot of detail. It's a 30-minute session, so there's a lot to cover. But hopefully by the end of this, you should know a lot more about mobile app decomposition. So I'm a security researcher at NowSecure. I do predominantly iOS things, but a little bit of Android. I've been in security for almost 10 years. The majority of that was in security consulting, but the last year has been in product. So mainly focusing on tooling that goes into CI/CD. So everything that's kind of bread and butter to DevSecOps. I like everything to do with mobile, pen testing, code review, MDM, that kind of stuff. But recently, static and dynamic analysis is what really excites me. And if you want to follow online or if you want to ask questions, you can find me on Twitter. I just had baby twins though, so I might be a little slow to respond. So yeah, the real core question that we want to answer today is how do you begin to understand if you're vulnerable to a given thing? So if you remember late last year, Sneak found a Sourmint SDK vulnerability that we'll talk about in just a little bit. And there's been other big popular vulnerabilities within libraries like Heartbleed, CCS, and then other high-profile things like Spectre and Stagefright. Not all of these apply to mobile, but the point still stands. When something significant happens and there's a cause for concern, if you have a large portfolio of apps or your employees are using a bunch of third-party apps, how do you know if that affects you? And how do you reliably know if that affects you? Even if you don't think you use that component, you might actually find that it's inside your app, even if you didn't know that. So the first thing we want to understand is what is a mobile app? What's inside the app? And if we think of it like a nutritional label, we can see here on the left, it's an Android APK. We can see that we have 37 total components, and maybe we understand that there's a breakdown. So 32 of these things might be open source, 3 of them are commercial. We might have a couple of proprietary libraries. Maybe the marketing team writes an SDK for us and the security team writes an SDK. But there's probably more to it than that. I think, this is just the tip of the iceberg. And we might know how many of those things have available updates if the vendor lets us know, or if if we're watching the upstream open source repositories. And we can also sometimes have a good understanding of whether any of those things are vulnerable. But again, there may be things inside your software that you're not actually aware of, and it's those cases that can really cause some headache and cause for concern for the business. So not just those 37 components are the thing that we want to focus on, but most importantly, what specific versions of those components are inside the apps. And those dependencies, do they have any transitive dependencies? Those libraries that we're using, they often have their own dependencies, which might have dependencies of themselves. And this becomes really complicated, as we'll soon find out. And essentially what we need to do is we need to develop and maintain an inventory, and we'll call that the software bill of materials, which basically details all of the components that we're aware of and various bits of metadata around them. And then using that and tracking that over time, we can actually gain an understanding of what the lay of the land looks like across our portfolio. And we can be quick to answer those questions of whether this particular license is a concern for me across my portfolio, or whether this new vulnerability found by Sneak or someone else affects me. And that's really the end goal, is so that we can actually understand transparently what the software is made up of. So as an example of just how complicated this can get, this is a tweet from David Weinstein, who's my manager at NowSecure. We took a look at the Iowa Reporter app, which is part of like a bit of a PR nightmare. They have over 65,000 dependencies inside their app that's React Native. And including all the transitive dependencies, the total number of components exceeded 950,000. So you can begin to understand how complicated it would be to answer the question of, is anything in there stale, insecure, or maybe a licensing concern for me when you have that sheer volume of components? You might think you only have a handful of dependencies, but actually underneath the scenes, you could have hundreds, if not thousands. So if we want to build this bill of materials, we need to start somewhere. And the NTIA had a working group who published a paper on software transparency. I definitely recommend you go check it out. And here's a graph that they've shown inside that document. On the right-hand side, we have our Acme application, which includes the Bingo Buffer package and Bob's Browser package, just obviously hypothetical scenario. And the Bob's Browser package itself includes this compression engine. So we can see in the graph, there's like a hierarchy to the dependency tree. And in a tabular format, in the component name column, we can also see the same sort of hierarchy to the component list. But there's also some other interesting information here as well, like the authorship information, and most importantly, the cryptographic hash. And that's extremely important because when we look at a snapshot in time of a piece of software and we identify certain components, then we need to say with cryptographic integrity that this exact version of a thing was what we observed, right? So sometimes you'll find that multiple builds are issued with the same semantic versions. So even if you know it's version 1.0.5, that doesn't necessarily give you extreme confidence of the exact snapshot of the thing you observed. So if we have a cryptographic hash, then we can use that to verify that it is exactly the thing that we saw before. So how would you actually build a bill of materials for your software? To be honest, most of the time you'll be doing this with source code. If it's in-house software that you're building, it's very easy to do. There's lots of tools out there. I'm not going to list them all, but for example, you can use things like OWASP dependency check, which will go out and actually try and find out if any of the components you have are subject to issues. It gets a little bit more complicated if you have black box applications or even components of your software which are black box. So let's say, again, you might have open source components, but you also use commercial libraries. It's unlikely that the vendors are going to provide you source code for the commercial components. So if you want to understand what components are within there, then you probably need to be doing software composition analysis on those binaries. You might also have third-party apps that your employees use as day-to-day business. So they could be things like expense tracking apps or receipt apps, things like Google Sheets for accounting and for sharing data. And you don't really know what those apps are made of or whether there's anything in there that might be a cause for concern, especially if you're using like corporate devices in MDM, for example. And then as another example, you might outsource parts of your development to other teams, or there might be segregation of duties, which means you don't have access to source code. And again, from an assurance perspective, we might want to do black box bill of materials generation just to gain an understanding of what's in there. But this is really hard to do with efficacy because you have things like compiler optimizations and code flattening and code minification. And then on mobile especially, you'll find often that a lot of components are obfuscated. So if you have like signature matching as part of your bill of materials generation, then you'll find that often your signatures might not match. And this becomes like a really difficult problem to solve. So the first part that we were trying to tackle is like, how do we identify components? So what if we go through a package and we identify that there's various libraries, how do we record that inside of a bill of materials? The first way would be to use a CPE identifier. It has like a semantic string that looks like this. I've highlighted in color the main components, so the vendor, product, and version, but there's lots of other metadata that can be captured here. As an example, we can see here for Internet Explorer, it's from Microsoft, of course, and it's version 8.0.6.0.0.1. And we can also see that, for example, it's using CPE version 2.3. And just before Microsoft, we can see there's an A, which tells us it's an application. So you can also have an identifier to represent software, operating systems, and hardware. Another way of identifying a component would be a package URL scheme. So this is something that's quite commonly used in some of the OWASP stuff. You'll see in the URL scheme, you have an ecosystem type, a namespace, the package name, and the version. Again, you can have other qualifiers or information as well. And again, as an example, we can see here it's a Maven package. It's in the Apache XML graphics namespace, and it's version 1.9.1 of the Batik animation package. So inside a bill of materials document, it might look something like this. You don't need to read the whole thing, but for our EMEA application, we have highlighted a CVE identifier. And then at the very bottom of this document, we can see there's another package URL for Tomcat Catalina. So just two different examples of how we might identify a component and track that inside a bill of materials. So one bill of materials format, which is quite popular nowadays, is Cyclone DX. This is like a product of the OAuth community. It's featured in things like dependency check and dependency track. It's quite flexible. It has JSON and XML formats, so you can work with most modern languages to parse it and generate these. There's lots of tooling around it. And as an example here, we can see we have the Catalina package and some licensing information. And then another format is the Software Package Data Exchange format, or SPDX. It's been around for a lot longer. There's a lot of work that's gone into the format, and it has many different data types that you can generate the bill of materials in. So it can be quite flexible depending on your needs. In the example, you can see down to the individual file, we can see information like which license was used, what the different checksums are, and if it was a binary or source code. So we can get like a granular understanding of all of the things that might be inside the software. So there are other formats, but given the time, I'm not going to go through all of them, but these are the two main ones that you'll probably run into if you start looking at software transparency. So to get an understanding of why this is important and why we should be talking about it, I wanted to show you some metrics. So what we tried to do was look at some recent events that happened. I mentioned this one earlier. The Sourmint vulnerability was found by Sneak, published late last year. And what they found was this Mintical advertisement SDK was serving with legitimate functionality for a long time, but then at some point was updated to include some illicit or nefarious functionality. And to begin with, what was observed was the advertisement library was hijacking advertisement clicks. So essentially, the user would click on an ad and the SDK would intercept that and send some fake or fraudulent attribution information back to the providers. So it shouldn't have been doing that, but that was already bad. But the more Sneak looked at the library, the more they found. And it turns out they were also doing some tracking, which involved even recording all of the things that Android users were downloading on their phones. And then on iOS, it was actually observed that there were ways for the backend to communicate arbitrary code that would be run in the context of the app. So essentially, the behaviors that are typically exhibited by malware. So this was pretty nasty. We actually, at DevSecure, we worked with Sneak on this one to figure out across our sample pool how far the rabbit hole goes, and this actually affected quite a lot of apps. So it was a big problem, and it stemmed out into other SDKs that we're using this underneath the scenes. And again, it becomes quite a hard problem to answer. Does this affect me? So again, it was high profile, and we had a lot of customer attention on this. Another recent story, which you might have read from Alex Bursan, was dependency confusion. So Alex found a really interesting supply chain abuse case where he ended up making quite a bit of money through bug bounties. And what Alex observed was that the order of which many package managers would fetch packages from registries could be abused. So for example, he went out and looked at various package files for lists of dependencies. And this one, for example, is from PayPal. And the one shown in red were packages that didn't exist at the public NPM registry and were likely, obviously, internal packages to PayPal. And what would happen with, when the package was installed, NPM would actually go and try and fetch them from npm.js, the public registry, before falling back to any internal registries that were defined. So this allowed for kind of like a race condition in a way, where someone with this knowledge could go and register those packages at the public registry. And then when the software is installed, it would pull in those malicious packages instead of the desired internal package for those organizations. And there was many companies that were affected by this. It was a very cool article, but just again, shows another example of where dependencies can become quite a mess. And the other big problem is on mobile especially, we see a huge explosion of different ecosystems. So we have things like CocoaPods and Carthage, Swift PM on the iOS side. We have Maven and Rust now, C++ on Android. You can have Rust libraries on iOS too. There's lots of cross-platform frameworks. So NuGet would be applicable for .NET DLLs, for Xamarin apps, for example. And then things like React Native and Cordova, very popular these days. So again, NPM as an ecosystem is very relevant here. And then we have even some newer frameworks that are starting to get a lot of traction, like Flutter, which has a language called Dart. So there's lots of stuff going on. And if we want to understand all of the things that are inside our software, then we also need to be able to understand these different ecosystems so that we can identify the components appropriately. There's no point in us identifying all the native components if the large majority of code is in JavaScript and we're not actually analyzing or looking at that. So to put this in perspective, we wanted to show some metrics, and we thought it would be a good idea to go and look at the top 100 apps in finance. So the chart might be a little bit out of date, but a few weeks ago I pulled down the top 100 apps in the finance category of the App Store, and began to pull out the bill of materials and look at some trends throughout. So the first thing that we looked at was what was the ecosystem breakdown, and we found that most components that we identified were native components on iOS, for example, using CocoaPods. Not totally unsurprising. Most of the financial apps that I've worked with in the past through consulting have been native apps. It's been very rare that I've seen a cross-platform app in finance, so this wasn't a surprising trend. But there were a handful in there that had JavaScript components and even Xamarin components, which I'd never seen before, but yeah, again, wasn't totally unsurprising. Another thing that was very interesting was if we looked at the software bill of materials size, as a general trend, Android was much more spread out, and often applications had a lot more components. So on the left of the chart here, we can see the percentage of the sample pool, and then the colors represent the number of components in the bill of materials. So on iOS, 75% of apps only had between 1 and 30 components, and we can see that the graph sort of tapers off, and the larger the bill of materials size. Whereas on Android, most applications had between 60 and 120 components, and there were still quite a large percentage of applications that had even 120 or 150 plus components inside the bill of materials. So it just shows as a trend that Android applications typically have a lot more inside them. That doesn't necessarily equate to any risk, but given the open source nature of Android, again, this wasn't totally unsurprising. In terms of licensing, for the components identified, most of them used Apache 2.0 as the license, very slight majority. MIT license came in at 37.2%, so just behind. And then next we had copyright and commercial licenses, which again, in finance, is not totally unsurprising, given that most of that code is going to be proprietary. Zlib and BSD also had a presence, but again, very small numbers. And yeah, very permissive licensing used inside commercial apps or proprietary apps is not unsurprising. We don't see any copyleft licenses here because, again, it's not likely that the banks are going to want to open source large parts of their code. They typically have lots of security and anti-fraud and obfuscation and stuff that's in there. And I can't see them wanting to make that stuff available online. So another interesting case study is we took a high-profile airline app. I'm not going to name them, and I'm not going to name the region they're from. But we saw that they had 43 total components, and 37 of those components were external. And what was interesting was over half of those components had available updates at the time we looked. So 20 out of 37, which is 54%, actually had available updates. Some of them, of course, would just be like a patch version, but some of them were multiple major releases out of sync. And these were for very popular libraries like Adobe Mobile, Alamo Fire for networking, app authentication, and even things like Zebra Crossing, which is for like QR code and barcode scanning. So again, quite surprising to see that very popular applications have such issues with keeping the dependencies up to date. You'd expect most software, in the stores to have some kind of, available updates. But when you're, a leading provider in a given field with very popular software, you'd expect this to be a bit more hygienic. 12 of those 37 dependencies or projects actually didn't really exhibit any activity online. So if we went to the GitHub or GitLab projects, there was no activity within the last year, no recent commits, no pull requests. The issues that were being filed were just abandoned, which again was kind of sad. But it still shows that even though you're using these dependencies inside your software, they could be a risk, even if it's not security risk. There could be business risk there because these things aren't necessarily going to be as up to date and maintained as you would like them to be if they were internal. Surprisingly, only 2 of the components that had available updates actually had vulnerabilities associated with them. That's not to say there weren't more vulnerabilities, but certainly in the public domain, only 2 components were showing up as vulnerable. I think it was 4 vulnerabilities in total, and I think that the maximum CVSS we saw was 6.5. But yeah, still, it goes to show there are vulnerabilities sitting inside apps that can be easily fixed through available updates. So this brings us to the problem of how do we actually generate or determine the bill of materials for a black box thing? If we're looking at a binary, if we don't have source code, if it's a commercial library, or we're looking at an app store app that maybe I don't write inside my organization, how do we determine what's inside it? And that's what I want to focus on now. So thankfully, or maybe not so thankfully, depending on your perspective, the package managers and the ecosystems often have a lot of residue that can allow you to determine what's inside the software. And sometimes you'll find that these files are actually included in the builds of the Android and iOS apps that make it out to the stores. So if you see, for example, package log files for NPM, you can determine all the packages that are installed, what the versions are, and all the transitive dependencies. You might also see things like pod files for CocoaPods or cart files for Carthage. But yeah, it's not going to be the case that every application has these, but sometimes you'll find them and they can give you a lot of insight. But down at the bottom, we've highlighted in bold the things that you're going to want to look at most. On iOS, we have frameworks, dynamic libraries, bundles, maybe extensions. If it's cross-platform like Xamarin, then we're going to have things like dynamic DLL files. On Android, we have DEX packages, so we can analyze those. We might have native libraries as well there, and there are other build artifacts like properties files that we'll want to look into. And then on both platforms, things like Cordova, React, Kone, Capacitor, all of these things have their own files on disk, which are pretty known and in standard sort of file system structure. So we can look for and identify those components and pull out the versions there as well to gain an understanding of what's there. So if we know all of this, actually, we can begin to look through it all and gain some perspective. It's not going to be completely comprehensive, but it's better than not knowing anything. So on both platforms, applications are just zip files, so we can just go ahead and unzip them and have a look through the files and directories that are in there. I grabbed like an Ethereum wallet, a crypto wallet, just as an example, and here we can see lots of Cordova plugins. We can see ES6 Promise plugin. They're using Google+. There's some keychain Cordova plugins and so on. We can also look at the Cordova JS files and actually just pull out the list of plugins that way too. But just even without tooling, if we wanted to do this manually, we could just sift through the data and have a look what's there. In terms of frameworks, we can do the same thing. We can see this application is using Protobuf. They're using the Facebook login SDK, the Google Promises, FBL Promises framework, as well as many other Google frameworks here. They all have this info.plist file, which is basically a manifest on iOS, which will give you version information. So for each of these, we can actually figure out the versions that are in use as well. So again, we can start to create a bill of materials on a black box thing, even if we don't have source code. On Android, it's much the same. So we might have native libraries like we have highlighted here at the bottom. So we have a Google OCR client. We can also have properties files. So we can see things here like log4j, we can see i18n and other packages that might be in use. So just even from looking through the zip, we can gain a high level understanding of what kind of software is inside the app packages. But we probably want to go a little bit deeper than that. So If we want to do code analysis, then we can convert the DEX to Smalley and then Smalley to Java. So this would be an example for Android. On iOS, we can use decompilers like Hopper or Ghidra or IDA Pro even to analyze those. But on Android, you can use some free and open source tools to do this quite easily. And although it might not be compilable Java, it's pretty legible. And we can see, for example, that we are using the Apache Commons packages. So again, we can start to piece together a perspective of all the different packages that might be included inside this app. Obviously, this is going to become quite difficult and tiresome if we're doing it manually. We can use tools like Radare 2, which has many language bindings for things like Node and Python, so that we can script it. Radare 2 is an open source reverse engineering toolkit. And in this case, we can use the ICC command, which will give us information on the classes, methods, and packages. The tilde symbol here in the command is a grep. So we're just grepping for the word package. And over on the right, we can see all the packages that are showing up inside this Android application. We can see lots of duplicates, so we'll probably have to like dedupe the data. So again, if we're scripting this, that's really easy to do. And then if we want to go deeper, we can actually analyze the classes to pull out the build configs and gain any version information that might be in there as well, so that we can get like a richer bill of materials rather than just the names of the packages. So that's identifying all the components that are there. Obviously, as I say, it's not totally comprehensive, but it's better than nothing. There's more to it, but obviously we only have 30 minutes today. But part two of the problem is like, how do you actually begin to work out what's a problem? So for vulnerability detection, we can look at places like Sonatype's OSS index. You have GitHub advisory, NPM advisory, NIST has the NVD. There's many places where you can get CVE information. You can go to the ecosystems directly to query information about available updates, what the licenses are. And then there's services like libraries.io that you can use if you're happy with the licensing around the data. And then Sneak, Sonatype, Deps.dev was recently launched by Google, but doesn't have great support on iOS yet. It doesn't support CocoaPods, for example, but is also very cool. So you can get information there. With licensing, you want to look at if you're using any copyleft licenses or anything that you might be violating the licenses for. So do you open source all the relevant components? Do you include all the correct license texts? Have you documented any changes? And yeah, basically just make sure that you're not violating any of the licenses that you're using. You might also find dependency lists without the log file. This is kind of tricky because it might just tell you the minimum version of the library that needs to be installed, and it's not easy to ascertain which specific version was installed. And we also might not see all the transitive dependencies. So ideally, we want to look at the log files if we can. And then not just whether there's vulnerabilities or security risk, but business risk. Are any of these packages we use subject to code quality concerns? We can use the GitHub API, for example, to look at how many issues are unattended, how frequently do they commit, what's the PR, the pull request cadence, is there a sufficient bus factor, the number of contributors to the project, if one of them were to get hit by a bus, would the project keep moving, or is our project also going to be affected? We can look at things like maturity. Do they use CI? Are there linters, test suites, documentation, and this kind of thing? I love this XKCD. It basically just shows that you might have all this great stuff, but you're held up by this one person somewhere around the world who has this core package to all of the thing you've built. And then we could also query whether these packages exist in the public domain. So again, the dependency confusion or the package squatting that we talked about earlier, maybe for all the components we identify, we'll check to see if they exist publicly, and then we'll flag it if not, to make sure that, that we're not going to get caught off guard there. And then, yeah, you want to do this over time because malicious code may come at a later date. You probably want to be doing more than SCA. You might want to be doing static and dynamic analysis so that you can identify nefarious behavior. But software composition analysis is a great place to start. So as an example, I hacked together some really lame scripts that would attempt to do this. I don't think it will ever see the light of day because it's rough around the edges and sometimes wrong. But it gives you an example. So here we can see a list of libraries we saw inside an app. a bunch of version information. We can see that there's available updates in some cases, and we can see the licensing information. We have multiple version fields because on iOS you have a short version and a main version. So we have to do a bit of hackery to figure out which version's likely to be correct. Often you'll find that some components use the version field and some use the short version. In this case, all of the components were consistent, but I can tell you for a fact that's not always the case. So you do need a bit of logic to make some assumptions, which is why it's not really necessarily always reliable. But for example, at NowSecure, we're working on this problem, and if you combine static and dynamic analysis, you can get like a really rich sense of what's inside the software. So lastly, I just want to throw out some links to some more information. Kate Stewart did a fantastic presentation just recently as part of the Linux Foundation. I borrowed a few concepts and the XKCD from her talk. Definitely go check it out. She's been doing a lot of work in the software transparency space and for SPDX, a huge set of resources there. Aladdin from Osterlabs also has a great talk on mobile app dependencies and all of the complications that come with it, which I also found really useful. So go check that one out as well. And then lastly, OWASP dependency track as an appliance which aggregates CVE information, gives you like an API for tracking your bill of materials and querying if there's any issues. It's come a long way even in the last few years, and I think it has a lot of potential. So I definitely would suggest going and have a look at that as well. And yeah, with that, I will take any extra.
That's it for wrap. I think we're done.
Fantastic! What a great day.
Absolutely. First of all, I think we should thank the team that is behind the scenes and doing all this stuff.
Absolutely, yeah.
Making sure that everything is visible, that sometimes when things are clunky, they fix it up while nobody notices that they're doing the hard job. I'm just a pretty face.
Yeah, they've done an epic job over the last however many hours it is now. I've forgotten, but it's a very long time.
I think it's 24. But don't want to be cocky. I think it's 24.
It's probably 24. The clue's in the name, right?
But yeah, it is. But also like all the stuff that went before this conference, this event, like asking people, like the CFP committee teams, like 3 CFP committee teams for America, APJ, and EMEA did a great job selecting these talks. All the speakers that did this amazing job of sharing their content to the world. Thank you so much for doing this. Without you, this was not possible.
And thank you to all our sponsors as well.
Yeah, let's go to I prepared my screen this time, Matt. I did. I did. You cannot catch
let's give them all a last shout out, shall we?
Yeah. Let's go to the event page one more time, and let's go through all the sponsors one more time just to give them a big shout out and a big thank you for helping us out. So as you can see, you go to the sponsor sites, and of course we have this famous company with a dog called Sneak or Snick, or well, as long as you don't say Snike, I'm okay with it. But according to Guy Pajarny, it's Sneak. Simon Maple would disagree with me, but however, we've got Bridge Crew, Stackhawk. How do you pronounce it? Irius
Risk.
Yeah, I don't want to mispronounce it, and I'm just a silly Dutchman, so forgive me for that. Teleport, Contrast, Sysdig, Trend Micro, Cloudbees, Circle CI, We Hack Purple, and Launch Darkly. So I want to thank. Sorry.
No, go on. Sorry, Brian.
I want to say just thank you for being here. I hope you had some nice conversations with the attendees and with speakers and with all of them. If you still want to continue conversations, everybody, that counts for everybody. Just go to the Slack and
of course all of the proceeds from the conference today are going to benefit global charities driving inclusiveness in technology, right?
Oh, that's a good one. That's actually true. If you want to know more about...
I'm glad it's true, Brian. I'm glad it's true, because otherwise that would be misleading.
Sure, it is true. Definitely is true. If you want to know more about the talks, I mean, the talks are already on YouTube. I have the DevSec on YouTube over here, and here you will see the... you can do this. This is magic. I can enlarge this. The DevSecCon24 2021 playlist, all the videos are there already. So if you click on
is the kids track on YouTube, Brian? Perhaps we can catch up with that on YouTube.
I'm not sure. I don't think so. I see people in the background like, no, why not? That is. You still can rate sessions like this session and put in a comment. Next time we want the kids session.
We want an adult sing along session. Session. Yeah.
Yes. Adult sing along with the lyrics in at the bottom of your screen. That would be amazing. Oh yeah, I already said that we have the DevSecCon Leadership Awards 2021. We're not doing that today. We're doing that during DevSecCon London. And DevSecCon London is the end of October 20th and 21st, if I'm not mistaken. But go to the DevSecCon website, and as you can see here, DevSecOps/DevSecOps-Leadership-Awards. That's the direct link. But you can, you can nominate DevSecOps leader as like the inspiring DevSecOps individual, the most effective DevSecOps team, outstanding DevSecOps community, and we would like to have your nominations in. And you just have to fill in this form. On top of that, we have something like SneakCon, right, Matt?
Yep, SneakCon is coming up. The call for papers is open. So please do submit your developer security related talks for SneakCon. I've submitted mine, and I know Brian's working on his, so that will be a great conference again. And if you've enjoyed our presenting skills, I'm sure we will be back again, Brian, at some point during that conference as well, right?
I hope that, like, as long as I don't make any silly jokes, they told me don't do silly jokes on the live stream, then it's okay. So I'm holding back not to make any silly jokes. But yes, do submit your stuff, sneak.io/sneakon, or well, /CFP in that case. But go to sneak.io/sneakon to submit your talks for SneakCon. It's a developer-driven community for developer tools. Well, if it is security minded, we would happy to do that. If it's not so much security minded, but kind of a bit, it's also good. Like everything that is developer focused for building your stuff, securing your stuff, CI/CD talks, everything that is developer related, we can use that. And please submit your talks up to, I think it was July 15th or something like that. It's over here, like July 16th.
And if you haven't already joined the Slack community, you obviously haven't been listening to us badgering you all day to do so. But please do join the community on an ongoing basis on the DevSecCon Slack. Press the blue button as Brian is showing you on screen there, and come hang out with lots of lovely folks in the community there. DevSecCon chapters we should talk about as well, Brian, shouldn't we?
Oh, yeah, DevSecCon chapters. That is a very, very good one. If you want to set up your own chapter, we have local chapters currently in London, in Germany, and in India. But if you want to set up your local chapter, please do so. Please, we can help you out. If you go, I think it's
under Get Involved, I think.
Get it? Yeah. Here you see the different chapters already, so we can add your chapter. And if you want to lead a chapter, you just go over here and help out. Or on the main page, there's a lot of stuff going on, and you can see what upcoming events are, but also how you can get involved. Like get involved here, submit a post if you have some stuff to share, propose a talk for the I think it's monthly now. The stuff we do the monthly stream, and if you have events or anything that can help the community, please feel free to share it here or on the Slack channels.
And of course, you can access all of the Secure Developer podcast as well through that page, right, Brian?
Yeah, or on your favorite streaming thing. Then I have to. I don't think this works. If I do this, you probably won't see my Spotify because I share the screen. But let me remove this one. And let me share another screen. I can do that. Look at me. Check a window, and I'm now sharing my Spotify screen, and we see that you have the Secure Developer over here, which is the podcast that basically our dear Sam hosts every single week, month. Well, a lot of times there are already I'm currently listening to episode 98. because I like this one. So go to your favorite streaming service, go to the podcast, and every time our founder, Guy Pajarni, will have somebody as a guest and will tell about something that is related to the DevSecOps mindset and how to build DevSecOps teams. So yeah, you can find it on all of the popular streaming services like Spotify, or maybe you're more into the Apple streaming service. It's also available over there.
Okay, well, I think we've reached the end of the road, haven't we, Brian?
We have reached the end of the road. Again, the team that is on the back end is doing this for a very long time, for almost 24 hours now. Thank you again. We're happy that you're doing this.
It's time for them to go to sleep.
Thanks again to all the speakers and to everybody who attended this thing. And let's move this further on Slack, will we?
Thank you, Brian. It's been emotional.
Yes, it is. Thank you, Matt, for being here with me. All right.
Bye, folks.
Bye-bye.